time to remember to actually post to Discord.
Siri_bot says Siri_bot has joined Cerebral Love.
I can't believe I missed these. I missed that there's more math curriculums. It's only cute. Sad. Wait, what category am I in? Nice. So loud. What is a complete angle? Reflex? Complete a reflex. Okay. This is new.
And this up wider. So these are both, if one measure or it's smaller, then it makes sense. So an acute angle will look something like that. I draw two.
Okay, but where do they introduce the terms complete, straight, and reflex?
Let's talk. So I'm turning complete rotated 3/4 straight angle, and we already know that the clock is.
But this is also from Khan Academy, right? Oh, Khan Academy, India.
The clock hand is going to move clockwise.
Wait, I should subscribe to this.
So we go.
Actually. Yeah. So they introduce a term that they don't define. Okay. So it's a reflex complete angle. I think reflex angle is always greater than a straight angle, which is a half circle. Okay. Reflex. And less than a complete angle, which is a full circle. Okay, that makes sense. That's weird. So this is a reflex angle. Grade 4. Oh, cute, right? Obtuse or straight. Cute. Bleep. Obtuse. Wait, right. Okay, it plays music when you level up. Cute. I have to go back and redo some of these. I'm missing. I don't think there's another 4th grade one. I think that's not what I want. Wait, where's the full list of courses? I forgot. See all math. Yeah, so the FL Best grade 4. There's no other grade 4. Just this. $110. Wait, how do I forgot how to automatically go to the next question. I think it's like tab. I want to try. Okay, it's not tab. Okay, shortcuts. Okay, maybe it's like enter or something. I swear there was a button. Not enter. What else could I possibly push? I mean, maybe if I... no. I really... I thought they had one. Maybe I'll try the insert button. 3, 4. Reflex. Okay, I'm gonna try insert. Nope. This one. Let me just try all the keys on the keyboard. Function. No. I really thought there was something. Center? No. Oh, okay. I just don't know. Oh, it had the. Oh. That's fine. This is easy. Why does enter not take you to the next question? Make any sense? Much faster to click, I guess. Really? It's 10, 20, 30, 40. Oh. Really? What? Because this is 5. No, it's 10, 20, 30, 40. Oh. Oh, jeez. And 20, 30, 40. Oh. Well, 66, 36. DEF. Hmm. Circle. Um, 6.
Corrupt converter says
5,
true
4.
equals equals
A.
false equals equals true equals false.
Hey, you're right. You're right. Wait, no. You give me PTSD about Python. That true equal false equals true. Hurts. Wait, that's not valid. Is that? Does that run? Oh, wait, true equal to false, so that's false. True equal to false. False equal to false. So true. I think. But hey, corrupt. I should raise the volume of the TTS since I can't like hear it well. What was the default that I had? Let me see. 6.9. Okay. Oh, depending on
Corrupt converter says is depending on the order of evaluation.
Yeah, good point. Also, I'm sad because I found out there's all these other curriculums. Like this one's called FL Best. I didn't realize there were more curriculums. I thought there were only like 3 more, but there's additional. There's like FL Best and there's one called like VOC or something. So now I have to do those too because I'm a completionist. I want to 100%. That means I have to do all of it. Oh, TX. It's called TX Tex. So probably like, I don't know, Texas or something. What? Shut up. It's because I didn't know.
You've been demoted to 4th grade.
I didn't know I'm not a Pega. I didn't know there was this FL Best thing. So now I have to do it. But it's okay, because after this unit test, I'm done with 4th grade. Then I can go to 5th grade, FL Best, 5th L, TX Tex. And then I can go finish 6th grade, FL Best, 6th grade, TX Tex. Oh, headache. Why? Actually, I think there's one more, actually, for 6th grade. There's like another... I forgot its name, though. It's like, I don't even know what standards where these come from, but probably somewhere... I don't know. Oh, I did not mean to hide that. Wait. Where'd my...
Corrupt Converter says
Why
you
did
didn't
it go
know.
away? Why
That's
did that?
why you
I
never
didn't hide
passed 4th
anything.
grade.
That's weird. No, it's because they... No. They hid it from me. It's not my fault. Okay. Let's say... It's supposed to be 40%? Oh, not that high. Okay. 7... I think this is what I used to have it on.
Corrupt Converter says
There we
it's
go.
precisely when you fail to know that you don't pass the grade.
Oh, well, I'm about to pass it now, so it's all fine, right? It's all good. It's all good. 8, 9, 10. Okay, 3, 4, 5. 540. Okay, last time I got this one wrong because I wasn't paying attention. 10, 20, 30, 40. Wait, 90, 100, 105. Okay, we're done with 4th grade. This is over. Just filling in the gaps. So, what's next? 5th grade. All the missed 5th grade curriculum. So that is, start from the top. Should be, not down here. Don't need to worry about illustrated mathematics. I did that.
Converter says actually I think that sequence of equals I sent as first message is true no matter what order you evaluate in.
Oh, that's cool. Oh yeah, true is false is false. True, false, false is... Yeah, that's cool. Say that later. Map. Where do I be? Okay, so we're doing on FL Best. So grade 5 FL Best. Oh, this one. It's called VASQL. SOL. Sorry. It starts from 6th grade. Okay, I need the FL Best 5th grade. Oh, nice! I'm lucky. I have them. It's all done. Okay. So there's nothing different about this curriculum. Grade 5 TX Tex. What do we got? Jesus. Are you serious? Why is TX Tex so different from like normal 5th grade? Like, why is there all this extra crap? Ugh. Okay, well. Now I know. Okay, well, this will take time. No, I'm so sad. I went from 6th grade to 5th grade. But I need to make sure everything's complete. What should I do? It's been a while since I visited this. I do want to complete this course too. And then there's actually another one after, CS51. And you learn a little bit of assembly in this course too. C assembly. A little bit of assembly. And then the SQL. Week. I think I was listening to this one. Jesus. Oh wait, thought I was gonna get an ad. So I think I had just finished. I finished this. What's this? This section on representation.
The sound or the pitch, one other number to represent the duration, like in the context of piano, like how long is the human holding the key down, and maybe with 3 years you're doing film or look per second, if pictures moving And in fact, even though there's only 30 or so of them flying across the screen. So we have a way now to represent even though there's motion pictures, it's like pictures that are giving the illusion of motion, even though there's only 30 or so of them flying across the screen. So we have a way now to represent information both as input and output, whether it's numbers, letters, images, anything else. Let's now focus on what's inside of that black box, so to speak, wherein we have algorithms, step-by-step instructions for solving some problem. Now, what do I mean by algorithm?
I think I'll switch category to this one. Oh, I'm watching this.
Algorithms or step-by-step instructions. Well, maybe if we were to turn this into code, and that's how we'll connect the dots ultimately today, code is just the implementation in computers of algorithms. An algorithm can be something we do in the physical world. Code is how we implement that exact same idea in the context of a computer instead. And here, for instance, is a very common application inside of a computer for your context. This is like the iOS version of the icon. And typically, if you click on that icon, you'll see something like all of your contacts here, typically alphabetical by first name or last name. And your phone or your computer lets you often search for someone's name at the very top, and it will sort of autocomplete, and it'll be...
Wait, I watched this. Actually, I think it was up here.
Having again, so but ultimately on these here, the act that is time one, so the correctness
Reach an hour.
All right, so now on efficiency in this way. No. All right, so with that in mind, let's begin to translate this to some actual code. And in fact, before we look today at one actual programming language, albeit a graphical one, let's consider something called pseudocode. So pseudocode has no formal meaning. Generally, you write it in English or whatever your own human language is, but you write your thoughts down tersely, succinctly, but precisely. You try to really convey your thoughts, not with a wave of the hand metaphorically, but step by step,
Corrupt Converter
precisely.
says I'll be back. I gotta remove the grass so I can't touch it.
Yeah, dude, remove that grass. That grass is evil. Bad grass. Bad grass.
I mean by this? Here, wave of the hand metaphorically, but step by step, precisely. So what do I mean by this? Here might be some representative pseudo.
It's poison. Yes.
Corrupt Converter says it's
poison. Dirt. It also is poison.
Via which I
and sand.
describe that third.
What's that line? Sand. It's coarse and grit, and it gets everywhere.
And finally, might be some representative pseudocode via which I describe that third and final algorithm. Some representative, but step by step, precisely. So what do I mean by this? Here might be some representative pseudocode via which I describe that third and final algorithm in a way that I could hand it to you, and you could do the same at home. Or I could hand it to someone at Google, and they could implement it in Android. Or I could hand it to someone at Apple, and they could implement it in iOS. So step one, I claim, was pick up phone book. Step two was open to the middle of the phone book. Step three, look at the page as
Yeah, I should speed it up a little.
I did, and now things get a little more interesting. Step four, if person is on page, I have to make a decision. Presumably, what should I do if John Harvard is on the page I'm looking at?
Okay, a little faster. That's good.
So stop and probably like make the call or email or whatever the goal might be. And so I'm going to actually indent this visually by a few spaces just to make clear that you should only do line 5 if the answer to line 4 is yes. Otherwise, you don't bother. The next thing I'm going to do, line 6, is consider another possibility. If the person I'm looking for is earlier in the book, what do I want to do? Well, I could describe this in a bunch of ways. I'm going to do this tersely as follows. Open to the middle of the left half.
No, I'm not going to watch this. That's not optimal. That's not optimal.
Says 15x speed is optimal.
No. I'm so glad that's not even supported. Oh my god, 15x. Crazy. Imagine if I could actually understand videos at 15x, how much I could learn in a single day. Insanity. This earlier in the book. What was this again? Book. Oh yeah.
Corrupt Converter says
Wait, middle
XQC.
of left half. Oh, because earlier, it's how books, you read books left to right. They're XQC, PVC, PTSD. Oh, that's how they, oh.
Corrupt Converter says listening to XQC talk normally be like.
That guy is crazy. I mean, if he talks like that, how does he not lose his voice? I don't even talk like that much, and sometimes I'm like, my throat gets sore. 15x speed, wow.
Corrupt Converter says always 15x speed.
Damn.
Open to the middle of the left half of the book, and then what am I going to do? Well, I've just kind of divided the problem into something smaller, but it's fundamentally the same problem. It's just a fewer number of pages. So I'm just going to go back to line 3 and do it again, because the problem's just getting smaller and smaller, presumably. Else, if the person I'm looking for is later in the book, open to the middle of the right half of the book, and also go back to line 3. But there's a fourth possibility, and it's failure to realize sometimes that there's other possible outcomes that make computers crash, or spinning beach balls, or the like, if a programmer doesn't anticipate some situation. What's the fourth possible situation when looking for John Harvard? If they're not in the book at all, and indeed I might get to the very last page and John Harvard's not even on that one, I better handle that and say else, like kind of as a catch-all, just quit altogether. And truly, often your Macs, PCs, phones, when they freeze, or again spinning beach ball or the like, and just weird things happen, that's just because some human made a dumb mistake and they didn't realize that you could somehow get your phone or your laptop into a configuration that they didn't anticipate. So we're going to try to handle that here. Now, this is just one way of writing pseudocode. There's no one way to do this. All of us in this room can come up with slightly different pseudocode, but I think you'll...
People who, when you speed up videos like this, it's like they're on, like, so much caffeine. This is, okay, I'm just imagining this is what XQC talks like. That's too much.
Find characteristic are certain, one way to do this, all of us in this room can come up with slightly different pseudocode, but I think you'll find characteristic are certain building blocks in all of our right answers. Here in yellow are what, as of today, we're going to start calling functions, technically speaking. These are like actions or verbs that literally, in this case, like tell me what to do. Next, we're going to have these things, conditional, sort of forks in the road, so to speak, that take me down this path or another, metaphorically, so I do this thing or something else. But how do I decide if I want to go this way or this way or this way or this way? I need to ask a question. And in programming, we'll typically use what are called Boolean expressions, named after a mathematician, Boole. And a Boolean expression is essentially just a question with a yes-no answer, a true or false answer, a 1 or 0 answer. It doesn't matter how you think about it, but it's got 2 possible answers. And so you can kind of think of these as being expressions with question marks, even though I didn't draw such. Person on page, person earlier in book, person later in book, those are Boolean expressions, and they just tell me whether I should go down one fork in the road or another. And lastly, there's this. Go back to line 3 in 2 different places. That represents what we call a loop, like some kind of cycle that's doing something again and again. Now, these are just a few building blocks here, functions, conditionals, Boolean expressions, loops, but you'll find that they're characteristic of so many different languages, one of which we'll look at today, another of which we'll look at next week, and those include indeed C and Python and other languages still. And so this is why we focus on these basics and fundamentals in these early days, because we're going to see them again and again. So even if you feel like that fire hose is hitting you sometime, we'll give you today ultimately more visuals by which you can hang on to so as to actually write code ultimately in different languages and solve all sorts of problems. Now,
wait, is that a metaphor? The fire hose keeps hitting you. What?
Why, which you can hang on to so as to actually write code ultimately in different languages and solve all sorts of problems. Now, we'd be remiss in not bringing up sort of what's behind characters like Spot and ChatGPT and other software artificial intelligence, and it turns out to get to the point of AI, we're actually going to need more building blocks than ChatGPT languages
Okay, I
and
think I need to
solve
slow
all
down
sorts
just
of
a
problems.
little bit.
Now, we'd be remiss in...
This part, because he's going to say more. I just need to speed it up whenever what he's going to say is predictable. Maybe 1.25 is good here. This part.
Not bringing up sort of what's behind characters like Spot and ChatGPT and other systems. Now, we'd be remiss in not bringing up sort of what's behind characters like Spot and ChatGPT and other software artificial intelligence, and it turns out to get to the point of AI, we're actually going to need more building blocks than just functions and loops and conditionals. It's not going to be quite that simple, but this has been a lot so far. Let's go ahead here and take a 5-minute break, and when we resume, we'll take a look not only at AI, but also a specific language called Scratch. So no cake just yet, but we'll come back in 5.
He say no pages yet? Doesn't really matter, but I'm just curious.
Specific language called Scratch. So no cake just yet, but we'll
Oh, no cake just yet. The cake is a lie.
come back in 5. Before we dive back in, I just wanted to call out a special guest that we have here today beyond Spot, someone who's come from even farther away. And in fact, if any of you have taken CS50X, the open courseware version of the class, or dabbled in it over the past few years in some of CS50's online social communities, you might have had your questions answered by a certain human from New Zealand. And she's come all this way today to spend this lecture with us. This is CS50's own Brenda Anderson. If you might come up for acknowledgement from all of us here. It's not much, but just a little token of our thanks. Brenda has helped truly thousands of students online for the past many years, and in fact, her own daughter has been the artist behind the duck that's about to loom large in CS50 this year and beyond. So thank you to Brenda.
He just handed her a pack of Oreos.
All right, right, so it's hard to escape a discussion of artificial intelligence nowadays, but we thought we'd use this as an opportunity to connect some of these dots, because indeed, over the course of the semester, we'll not only be talking about artificial intelligence, or AI, but really using it all the more constructively to help you solve problems, help you get unblocked when you hit a wall, cognitively or syntactically when writing code, and indeed, it's no accident that we have this duck here looming large, which is really the embodiment of the sort of AI that you'll experience within CS50 itself this year. So let's talk about the so-called chatbots that inspired some of those headlines with which we began class that weren't quite on the nose. So the class will still be taught by us humans, but helped by this sort of CS50 duck, a chatbot of sorts. Now, what do I mean by this? Well, it turns out that when it comes to implementing something like an artificial intelligence, we don't quite have all of the building blocks yet, certainly after just today's week 0, to implement something like that, but I think we can sort of skate in that direction intellectually. So for instance, if we were to take a stab at implementing our own chat bot, some interactive text-based program that talks to us and answers questions and the like, we could try borrowing some of today's ideas already, those functions, conditionals, loops, and more, and I could write something like this. If I am writing code or pseudocode for a chatbot, I could program the chatbot to do something like this. If the student says hello to the chatbot, then the chatbot should say hello back. Else, if the student says goodbye, well, the chatbot should say goodbye back. Else, if the student asks how you are, the chatbot should say that it's well. But things get a little harder when you start asking more interesting questions, like, else if the student asks why 111 in binary is 7 in decimal. Now, you could imagine that we just have a conditional with this Boolean expression that programs the chatbot to just give you the answer and explain in an English sentence why that in fact is. But what if you, the student, asks why 110 is 6 in decimal, or why 010 is 2? I mean, you can just imagine the explosion in the amount of code that we would have to write to just anticipate every darn question that you might ask about today and every other class, not to mention all of the knowledge in the universe. So surely there are other ways to implement algorithms that allow something like a chatbot, or AI more generally, to be fed input still, like all of the internet, all of the World Wide Web, all of the pages and textual content therein, but to let it just figure out how to answer our questions based on those kinds of inputs, assuming the inputs themselves are accurate. So large language models is a term you might have heard bandied about over the past several months, or LLMs, and a large language model really is an implementation in software of code that actually takes as input lots and lots of language, like the text of lots and lots of web pages, dictionaries, encyclopedias, Wikipedias, and the like, and sort of infers from the patterns of English words or any human language what a typical human might actually say when asked a question. And some of these questions are easy, right? Probably on the internet alone, not to mention everyday life, if someone extends their hand and says, hi, how are you? Odds are, like with 90% probability, you're going to say, good, thanks, how are you? So I bet we could write software that just infers what it should say probabilistically, statistically, based on those kinds of patterns online. And that's indeed where the world is starting to go when it comes to the most sophisticated of algorithms, where you and I, the humans, we don't try to anticipate every possible input. Rather, we give it a more general purpose input, like all human knowledge, and ideally just let it figure things out. Now, we're not quite there yet, and odds are you've heard of hallucinations or just mistakes that these large language models make, but their inputs are imperfect. And sometimes there's a bit of randomness sprinkled in, because you don't want the thing to always say the exact same thing. Even you and I might say, I'm not that great today, 10% of the time. So you need to sort of perturb the output in some way. But within CS50,
Deter?
there's a bit of randomness sprinkled in, because you don't want the thing to always say the exact same thing. Even you and I might say, I'm not that great today, 10% of the time.
Oh, 10%.
So you need to sort of perturb the output in some way. But within CS50, and within this world of large language models, we do have these tools like ChatGPT and Bing Chat and others, and we'll stipulate that for CS50's purposes, the direction we're going this year is that this is what's in the syllabus, ... that it will not be allowed, it will be considered not reasonable to use AI-based software other than CS50's own. So the goal here is not to simply take away tools that are clearly inevitable, in my view, and clearly helpful and productivity savers, but we'd like there to be some guardrails intellectually on just how helpful these chatbots are, because as you've probably seen, if you ask it a question, these chatbots are already pretty good at not just helping you finish your current thought, but it'll hand you your second and your third thought and sort of do the assignment for you. But I think through prompting, so to speak, we'll be able to coax some of our own tools, being computer scientists ourselves, in a direction that you actually find to be the right balance, akin to having a good tutor by your side 24/7 who doesn't just hand you answers, but indeed tries to lead you to...
Oh, that's what this CS50.ai thing is then. Let's see. Log in, wow. Okay.
Do the same, so you actually get something out of the experience side 24/7 who doesn't just hand you answers, but indeed tries to lead you to the same, so you actually get something out of the experience, and ideally 3+ months from now, those training wheels can come off too, and you're able to still stand on your own. So it will be...
Did he say years from now?
3+ months from now, those...
I don't even know. It's telling like 3 + 1 from now.
training wheels can come off too, and you're able to still stand on your own. So it will be reasonable to use CS50's own AI-based software, which will actually take the form of a CS50 Duck, which is actually available now, and we'll use it throughout the term at CS50.ai, a web-based application that's quite similar to ChatGPT, but that has the personality of a CS50 teaching fellow, or TF, or teaching assistant TA, that also happens to think of itself as a duck. And for reasons we'll get to in a couple of weeks' time, but rubber ducks in particular are kind of a thing in programming. But more on that before long, as you can even see from the one there on my desk. There are kind of a thing in programming, but more on that before long, as you can even see from the one there on my desk. With that said, too, allow me to call out CS50's own Brenda Anderson, whose daughter Sophie kindly not only created the first incarnation digitally of this duck, but also most recently, once it actually did more than quack a random number of times in response to questions, has now been virtually brought to life too. So all that and more over the coming weeks, but you'll find ultimately that the goal is to really bring to life the event it actually did more than quack a random number of times in response to questions, has now been virtually brought to life too. So all that and more over the coming weeks, but you'll find ultimately that the goal is to really bring to life the availability of an AI-based tutor that you have access to, a friend in your next to you that will help guide you through a lot of the course's
Friend in your next queue.
challenges along the way. And a friend in your next to you that
Oh,
will help
next
guide
year. It's just kind of hard when it's going at 1.25 speed, I'll be honest.
you through a lot of the course's challenges along the way. And we've actually rolled it out this past summer already with some of your predecessors through the Harvard Summer School. One student wrote at summer's end that this duck felt like having a personal tutor. I love how AI bots will answer questions without ego and without judgment, generally entertaining even the stupidest of questions without treating them like they're stupid. It has, as one could expect, an inhuman level of patience. So there's actually something really there, because as many teachers as there are in CS50, myself, the course's preceptors, teaching fellows, teaching assistants, and course assistants, there's only so many of us, and we're only awake so many hours of the day, and I think you'll find, too, that we're on the cusp of something pretty remarkable in the coming years, where it's going to get a lot more enabling now to learn material not only within the confines of a class, but on your own ultimately as well. And as one other student put it at summer's end with respect to the duck, love, love, love the duck, we're friends now. So that too awaits. But first, we're gonna need to start with the basics. And we started today by talking about binary, and darn it, here it is again. So we can't actually get to the point of using or solving or implementing AI until we understand this. And odds are most of you won't know at a glance what this piece of software does, but these are the zeros and ones that represent perhaps the first program that any programmer writes, which is now a clue to some of you who have dabbled in code before. What does this pattern of zeros and ones tell a typical computer to do? Might someone guess? It's going to have it say hello world, which is one of the very first programs that most any programmer writes. Should you be able to recognize these zeros and ones? Do I recognize these zeros and ones? Like, no, not at all. I just happen to know that they are the same, and that was kind of a leading question. But they are representing data and instructions, ultimately. Data like HELLO, comma, WORLD, and an instruction like print that data to the screen. As for what these patterns of zeros and ones are, this is not something that a computer scientist or programmer worries about. We just stipulate that, okay, someone somewhere knows how to do this, and it's probably someone like Intel who makes the hardware inside of the computers. But you and I, starting now, already in week 0, can start to view binary more abstractly. We don't care about the zeros and ones. We only care that you can use zeros and ones to represent more useful quantities like numbers and letters, colors, and more. So this, next week, is going to be the code we actually start writing at a keyboard, and this is that language called C. It's the same language I myself learned years ago when taking CS50, when all we learned at the time was C. But this, too, has some crypticness to it, and if you've never program before, you can probably wrap your mind around, okay, I'm guessing the printf prints out the hello world, but what's with the semicolon, the quotes, the \n, the curly braces, the hash include, and all of this stupid syntax? A lot of this in the beginning of any class is really a distraction. It is not intellectually interesting, but it's the stupid kind of stuff that's going to trip you up quite often. And so today what we'll do is focus not on syntax, characters on the keyboard, but ideas, because what really matters in this program is that printf is a function here for our purposes, and that function is to display information on the screen. Everything else, as we'll soon see, has value and will be understood by you before long, but for now it's a distraction. Let's focus on those building blocks. When it comes time to write code, though, for the curious, especially if you've programmed before, we'll use a very popular free and open source tool called Visual Studio Code, or VS Code. We'll use a cloud-based version of it that we pre-install everything you need in the cloud for you, so you don't have to deal with headaches like getting your Mac or PC to work. You'll use instead this URL, cs50.dev, but more on that in next week, week 1. For now, we'll use another cloud-based editor.
Wait, I'm on the next part. Okay. Do some of this. guess I'll do, I don't know, maybe these 4. Oh! I was like confused. I'm like, isn't this like 7th grade? Wasn't I doing this in that one, that course? But, my bad. On the wrong tab. Right, TX text. Eight. How much should I do here? Honestly, depending on how I'm gonna get wrong, I could just do all the white boxes in unit 1 if they're easy. Wait, what? Oh, rounding. I think 284. Yeah. $1,000, so 19. Hmm. 500 hex. It's gonna be 20. 0, 0. 0, 0, 0. 4 zeros? How many zeros? $200,000. Oh yeah, this thing's called the standard algorithm. Just kind of replace Y with. Should this be 20? Oh. We have one. Damn it. Oh, Y. I thought Y was over here. Oh. Bit more. Wait. Oh. What was this one? Destination. Oh. Okay. Shouldn't have done like that. They're going to make you do it the long way. God. Maybe I should have used a... No, it's only 4 problems. It's not a big deal. I hate drawing with a trackpad. Oh my god, I'm spot. Okay, wait 2. 0. 6. That's a 4. Okay, 2. What number was this? 8. Oh, that looks like accessory match. Okay, 14. I hate it here. 10. Oh my god, what even did I draw here? What is this? I don't even... I think it's a 5. Jeez. They don't, like, give you enough space. Maybe I should have done it over on the left side. And stop using a trackpad. Let's see. 91. Should be 9. Not 6. What did I do wrong here? 2, 15, 14, 15. So there should have been a 1 here. This one. 6. 4. 2. So that's 42. Oh wait, there was a 5 up there. Should have been 47. Damn. So it would have been 7 plus 5, I think. And that would have been 13. Damn it, it's too messy, I can't read it. Oh, okay. I'm just gonna plug in a tablet. I knew it was gonna be kind of annoying. Where is my tablet? There you are. Where's the pen? Was already plugged in. I don't know how many pen is. There it is. Oh, I'll reach again. Is any better? 2, 18, 15. 6. 50. Oh god. 7, 5. 2, 47. This would be 47. Ten, 7, 8, 9, 4. Okay, that's what I want. Oh my god. Oh yeah, that's 4. 2, 7. 2. Okay. 3, 2. Yeah, I corner 3, 2, 2. 6. 0. 20. 21. 5, 7, 5, 2, 2. Two, 23. 6. 12. 4, 8, 14. 6, 4, 6. 4, 6, 7. 17, 66. 10, 23. What did they round to? 2,100? Yeah. Wait. Or 0, but... Oh. Circle, circle, square. Hey, that game. That's the fun
Corrupt
game.
Converter says
I know.
Square.
I feel like I'm playing the
Circle
circle.
square.
Square.
Circle
Circle.
square.
Square. Circle.
Circle
Square. Circle.
square.
Square.
Circle square. Circle square. Circle square.
Square.
Circle
Circle.
square. Circle
Square.
square. Circle
So if it's
square.
600,
Circle square.
3,
Circle square. Circle square.
200,
Circle square.
circle
Circle square.
square,
Circle square. Circle square. Circle
square.
square.
Make it
Circle
30
square.
bags.
Circle square.
300. Circle square. Okay, 360. Wow. 18%, so 90. Wait, that says my number wasn't each bag. 30 bags. Oh, so just be 3. 9. That kind of was. What? 9, 18, 20. Oh. Circle square. Can't do circle square. I thought he wanted to run it like 3 goes into 36. Oh, I'm stupid. It's 12. Circle.
Corrupt Converter says
Square.
circle square.
Shoot. I hate division. Annoying. Okay, it's 3,060. 306. 50. 240. So it's like 420. 5. 13. By the way, Corrupt, did you know last night when you were playing Plague Inc., but then you explained like the fraction thing and you remember you reduced it to like 8/5? That really helped me a lot. Because then I like finally understood like why you can do that. It really did. Yeah, because you were able to do it so quickly, and then I was writing stuff down, and I was like, you know what?
Says, yeah.
I see the pattern. I get it. And then you don't have to worry about the bottom of the fraction, the denominator of the fraction that's up, the one that's on the top. You don't have to worry about that one because of like, if you cross multiply, like it ends up not mattering. So you can just do the top one and then the bottom one. It's really cool. Anyway, I finally it clicked. Something clicked. It was cool. 8,000. Oh wait, 20 to 80. Well, 20 into 2 into 800. Wait a second. We use 42.
Corrupt Converter says my school be like.
Oh my
Now that
god.
it makes sense. Do it 297 593 5773 times.
Is that what your school was like? Like they were really big on the repetition? I don't think that's too bad of a thing because my school didn't have a lot of repetition. You learn it once. That's actually, I think that's pretty good. I don't know. Because like
Corrupt Converter says yes.
Seriously, like my school, they give you one sample problem and then you get it right one time. And they're like, oh, congratulations, you know it. Let's move on. And it's like, well, I got it right one time. That doesn't mean I understand why I got it right. And then that's why I have like a bad foundation. So maybe it's not a bad thing. practicing something. But that number you wrote, that's too much. That's excessive. Maybe not that many times, but just like half that amount, you know? Half that amount. I guess they turned it to 8,400. So then it would have been 840, 20. Okay, I keep remembering. 420. Wait a second. Or 42. I don't know. Because if I take off one of these, then it would have been like 2 into... I think 420. Okay. Served 90 tables that day. Okay. It's gonna be 72 and 9. Same apples. Yay. Should I look at another... Oh, where's exorcism? Oh, there it is. Another exorcism thing. Do assembly.
Corrupt Converter says do assembly.
I could look at what assembly they have here. I join the track. Or maybe I should wait until they teach about it in this course. I think... Wait, where do they talk about assembly? What's in here about assembly? Data types. I wonder if they removed it in this section of it. Does anything show assembly? I think they took it out in the recent version of the course, but there used to be assembly. In it, but maybe it was like an older version. This one. What section is the course in this? Where does this even show up? Huh. I don't even know how you navigate to this page. What the... Anyway. Where was the website I was using before? Where's exorcism? There it is.
Corrupt Converter says that looks like fake assembly they have here.
Fake assembly? Really? I didn't... Oh. Oh, I see. Lol. Even this one, this jump EQ, looks fake. What is
Corrupt
this?
Converter says yeah, that's not real assembly.
This is like pseudocode assembly, so that it's easier to understand. Is that why they wrote it like this? Well, it'd be JE, not jump.
Corrupt Converter says well, it'd be JE, not jump heck.
Why did they do this then? This must be... What if it's, Remember there's like another kind of
Corrupt
assembly?
Converter says, and why does it have 3 parameters?
Remember you said there was another assembly that you don't like not the Intel one, but the other one.
Corrupt Converter says JE has no parameters.
Damn. Damn, you're really gonna do Harvard like that? This is Harvard, so it has to be right. I'm just kidding. Interesting. Oh, okay. Is this just a different
Corrupt
syntax?
Converter says look up Intel ASM syntax vs at.
Oh, you're saying this is not? You don't think this is AT&T syntax?
Corrupt Converter says
Oh, wow.
the syntax here does not exist in any assembly I know of.
Oh my god. I wonder if they like made their own version of assembly and they like renamed stuff, or I don't even know. I think that's weird. Because it even says to copy the oh wait, it says copy the program below. That's so
Corrupt
weird.
Converter says yeah, that one there you pulled up the image of.
Oh, it's made up. It says consider a simplified assembly language. It's just for like educational purposes. They're using like a simplified. They made up like a pseudo assembly. That's what that is. So that it would be easier to understand. Hmm. I don't know if I'm gonna be able to do it, but we'll see. I wonder what assembly's like on here. I was reading this last time. Oh, the 86 instruction set.
Corrupt Converter says look up assembly at.
Oh, okay. That's nice of you.
Corrupt Converter says or actually, I'll get on my PC in a bit and send you sample code.
Okay. Will it be simple sample code? Because I do appreciate simple. This is based on the original 86 instruction set from 1978. Okay. Assembly language is different from high-level languages like C# and Java. There are no variables, objects, or loops. Instead, you will have to deal with registers, memory addresses, and jumps. Okay. I wonder what the difference between a register and a memory address is. Maybe that's worth Googling. Because I think that's going to be important. And I don't think they're going to explain that. They don't explain anything in Exorcism. I'll find out. Okay. I hope so.
Corrupt Converter says you'll find out.
Learning assembly can be intimidating at first, but it will give you a better understanding in how your computer works. That's definitely what I want. It might even improve your programming skills in higher level languages. It's just what you said. Okay.
Corrupt Converter says registers are not stored in memory, they're stored on the CPU.
Oh, okay. Cool. It's good to know. Key features of assembly. Fast. As an assembly language, x86-64 cannot be beaten in pure execution speed. Stable. With an enormous install base relying on stability, changes since introduction have been minimal. Detailed documentation. Given its widespread and critical application, 86-64 has been exactingly... I've never heard... That's weird. Shouldn't they just say exactly, not exactingly? Cross-platform. Sure. What do you mean, sure?
Corrupt Converter says cross-platform sure.
Has been exactingly documented. x86-64 powers the most capable desktop CPUs in the world. It's so powerful. Oh yeah, cross-platform has been adapted by AMD, Intel, NVIDIA, VIA, or whatever. I've never heard of VIA for their CPUs. x86-64 has been the dominant instruction set for personal computer CPUs since 2010. Since 2010? Isn't this like really late? Shouldn't it have been like earlier than 2010? Or I don't know. Maybe because there was like an older assembly, like there's that other one for like 32-bit or something, I don't know.
Corrupt Converter says cross-platform, I doubt TBH.
Yeah. Has its own way of doing things, is no different, blah blah blah. I think this is the same thing, it says this is for every language.
Corrupt Converter says your assembly code on one device can easily not work on another device.
Oh, yeah, that's not very cross-platform. I think what they mean is they adopted assembly, but they like implemented it differently. But it's still like assembly, but different or something. I don't know. But it's kind of misleading what they said with cross-platform. If anything, that's misleading. They'll help your service and you don't know. Yeah. 36 exercises help you write better code, discover new exercises to progress. New concepts and
Corrupt Converter says maybe the language can be written and interpreted and run on multiple platforms.
Oh. Oh, I see. Like you use JDoodle for assembly. Like you can use it like that in that way, I guess. Okay, so I guess I'm joining this track then. Ooh, video.
Corrupt Converter says but the interpreted output machine code might not be.
Oh, okay. It's interesting. Some language, like some tracks. Unlike some tracks, 8664 assembly doesn't have a learning mode yet, so you'll be completing the track's 36 exercises in practice mode. If you'd like to learn the 8664 assembly from scratch, take a look at these supplementary resources that we've collated for you. Okay, what do they have for me? Track specific. Learning. How do I navigate back to this? I wonder. Well, maybe I'll just, I don't know. I don't know if I should bookmark it or not. If it'll be easy to find this. How to learn. I don't know how to get back here, so I'm just gonna bookmark.
Converter says open up this website, https://www.com/x86.
Yeah, you recommended this one before. Gotcha, wait, hold on a second. Need to close this back again. Okay, just opened again. Wow. Okay. I think I bookmarked this page too. An overview how to get started from scratch. Exercism provides exercises and feedback, but can be difficult to jump into for those learning assembly for the first time. These resources can help you get started. NASM tutorial. What's this one? Okay. What's this one? This is for Linux, though. I don't really want this one. Actually, can this be used even if you don't have Linux? Oh, you need a distribution of Linux for this tutorial. Here are the links to each post, but maybe there's like information that might be useful. I don't know. Okay, now I have so many tabs open, it's crazy. My computer might explode. Oh, this one?
Corrupt Converter says oh also.
Okay, I'll click on this. Ooh, that's all. Oh, cool. Is this like JDoodle, but different? I'm gonna sip some water. Write code on the left, see what it compiles to on the right. Oh,
Corrupt
cute.
Converter says you can write code on the left and see what it compiles to on the right.
Oh, so it'll show you like what the assembly looks like as you write the code. Like you'll see the assembly pop up. That's really cool. Like super cool. What? Oh, this one's C++. Let's see. Do they have other ones? Like, oh, C#. Oh, damn. What's this? Oh, this is the bytecode, isn't it? Oh wait, but this is
Converter
like...
says and you can highlight a line on the left and it highlights the corresponding line on the right.
Really? Oh, highlight line on the left. Oh, wow. That's cool.
Corrupt Converter says maybe not this one, I don't know.
Yeah. I mean, it kind of, this part, the move stuff looks like assembly, but what is, I don't know what everything else is here. Wait, maybe this is, does this look like assembly? For for C#? Do you? Yeah, the C and C+
Corrupt
one does.
Converter says what I'd recommend.
Yeah. Huh. I just was curious what it would look like, that's all. On the right side.
Corrupt Converter says is coding basic stuff in C, nothing crazy like opening
Yeah,
up windows or
there's
anything,
limit.
but just things like storing to variables or doing operations.
Yeah, it's still a helpful learning tool for the simple things just to see.
Corrupt Converter says and seeing the assembly it compiles to.
Yeah. Oh, cool. Except I haven't learned C yet. I haven't learned C++ either yet, but I should. Yeah. You think
Corrupt
so?
Converter says you know basic C.
You think C# enough? Okay. Anyway,
Corrupt Converter says same syntax for the most part, same keywords.
well, that's cool. Okay. If you change your mind later, want to work on your own. Wow, I don't even think I'm gonna be able to do this hello world
Corrupt
thing.
Converter says just assume you have no access to outside functions or any object types, only access to primitive data types, and you're good.
Wow, okay. Just outside function. No print. Wait, maybe no, there probably is like a print. Actually don't know. I don't know, maybe not. What does this look like? The hell? What the hell? I don't know. I don't know what. I don't even know.
Converter says whatever code you'd write in C.
I'm gonna just. Copy this in. But what is any of this crap?
Spit_PV says hello.
Oh, hey, Spit. Hello.
Corrupt
Hey,
Converter
sorry.
says that'd work in both C and C.
Yeah, it's assembly. int x3 equals 4 c equals 8 times b. C and G sharp. Oh, if I did int equals 3, yeah, it would be both C and C sharp. That's cool. That's good.
Corrupt converter says section.text means after that line is your code.
Section dot. Okay. Let me think. Section dot text means.
Corrupt converter says section.row data is the section for read-only data.
Oh, row data, read only. Oh, cool. Section. After that line is your code. Oh. Wait, the one that section dot text. Where? Oh yeah. So my code starts after section dot text. Does this space matter? If I delete, like, if I delete this, does it matter? Why is it? Maybe it's just it doesn't. Assembly doesn't care about spacing,
PV
right?
says at corrupt converter you're in computer science or something.
Default rel means, but it's probably not important. Okay.
Corrupt
Yeah, it's probably not too
converter says
important.
at spit_PVI code.
So read only data. Hello world. MSG. But this MSG is probably not the tasty stuff. It's just message. DB. I wonder what the 0 is.
Spit_PV says I code X.
What about the DB and the 0? Global hello. Is this like almost like naming a class or just like naming a section of the code? I don't even know. Like this reminds me of like public or private or something. Hello, Lee Rex.
Spit_PV says so you're a math coder and somehow you code in assembly.
Ah, storing that
Pixel
string as an array of bytes. Pseudo. Oh, that's okay. But it's okay. So it's an array.
Corrupt converter says
That's
the
so
0
interesting.
though.
An
I
array
forget
of
what that
bytes.
means.
Okay. And then we have the Lee, Rax, and Ret. Maybe. Let's see what some of the other sources have to say. Oh, Jesus. There's so many things. Lee? Oh. Should clear. Load effective address. Okay. What the heck? I don't understand any of this up here. Storing data.
Spit_PV says why are you learning assembly at salttoserenity?
Computes the effective address of the second operand.
Spit_PV says at corrupt converter yeah but what?
Loading a memory address. Okay. That's good enough for me right now. Load a memory address because it's too much information.
Corrupt converter says at spit_PV because it's very helpful for learning important general skills.
Yep. Yeah, I will. Got you.
Corrupt converter says salt. Look up what DB means in assembly.
Or let's see if it shows up in this list. I don't think it will. Or maybe it will. DB. I guess not. I'm gonna look up here then. Just DB.
Corrupt converter
Data
says I
bytes.
don't think it will.
Yeah, it didn't, but data byte to allocate some space and fill it with a string. Okay.
Converter says
So then, yeah, they're gonna put a string in here. I'm not sure about the 0.
Spit_PV says at Corrupt Converter you seem like a senior C/ASM programmer that likes math.
Okay,
That's an
section.
interesting combo LUL.
No data syntax. Yeah, Corrupt knows a lot of things. I don't know, it looks like just people asking questions about stuff not working.
Corrupt
Yeah.
Converter says there's likely a resource somewhere
We can
that
probably
tells us what
find-
each of the things in that DB line mean.
If I use the resources that were linked to, let's see. This tutorial, what is NSAM? Whatever.
Spit_PV says do you code in C?
Not yet.
At salttoserenity.
This tutorial will show you how to write assembly language programs on the 8664 architecture. You will write both standalone programs and programs that integrate with C. Don't worry, we won't get too fancy. Your first program. This looks different than the... Oh, this is their Hello World.
Corrupt Converter says which is enough for the basics.
Oh, this is for Linux-based OS. Oh, damn. Mac OS. Dude, they don't have a Windows. I don't know. Maybe it doesn't matter. But this looks very different. Doesn't this look... Oh, except for this part. This message, hello world part. Looks the same. But this part up here looks different than what they're showing me in Exorcism, doesn't it? Because all you have is this Lee Rax, but you don't have that other long list of stuff. Oh, like it won't, let's see.
Converter says yeah that hello world. I thought that 0 shouldn't be 0. Corrupt Converter
God.
says
Why is it missing the other... That's weird. But it's like, I don't know.
Spit_PV says at Corrupt Converter not the same at all. If you don't know what's a heap and a stack and take assembly courses is like driving a Formula 1 but you don't even how to start a car. Corrupt Converter says at spit_PV got bold and knowing how to use primitive data types is enough to get started.
It's actually what like Corrupt did, and he ended up learning a lot from assembly. Yeah, because he's done it. So that's why he's recommending it to me.
Corrupt Converter says I know because I've done UT.
But there's many ways to fry a fish. Not just one pathway.
Spit_PV says don't be a teacher bro. Just share funny things Kappa.
I like the things Corrupt shares with me. He's great. I'm sure you're joking, but like, yeah, don't mini mod. Because I've learned a ton from Corrupt. Anyway, what was it looking at? 1 second.
Corrupt Converter says, and I don't expect them to learn enough assembly to make an entire application like the Roller Coaster Tycoon dev did. But that's not the point anyway.
Yeah, I'm not going to build an entire application out of assembly. I'm just learning a little bit more about how the computer handles instructions.
Corrupt Converter
Yeah.
says just things like basic math and string manipulation.
Because having a basic understanding of assembly is going to be helpful for thinking about, you know, what my code does. And like C# and you know, in higher languages. NASM and GCC are installed. The one thing that is kind of confusing
PV
though.
says your pathway is impractical. You'll do a lot of back and forth between C and assembly and computer science classes and logic just because the order and abstraction levels you're following is bad. Pixel Bob.
But all these things are related in a chain. Besides, you don't have to be a purist. In any case, like, you know, it didn't hurt corrupt. I wonder if the 0 at the end is adding the byte value of 0 to the end. Oh. How big is a byte again? It's how many bits?
Spit_PV says if you want to lose time reading docs you're not supposed to. Why not?
Why not?
LUL.
8 bits, thank you. 8 bits is 1 byte. So maybe having the 0 is like telling it the string's over? I don't know. Why do you think though? So you have the message hello world, and then you have this stuff, the Lee racks, and this, whatever this is, return or whatever. Parse between string and int and string and float.
Corrupt Converter says all I did was parse between string and int and
Much
string
easier to
and
do.
float and make a basic calculator in assembly, and after that I noticed that all my high-level coding was much easier to do and understand.
And you made a calculator, not a calculator, but you were able to do like addition with subtraction or something, that was one of the challenges. Do all your, or was it do subtraction with addition? Like do all your subtraction with addition? Something like that. That was cool. This one doesn't have a row data thing. NASM is line
Converter says
based.
3-bit addition using only subtraction.
Three addition using subtraction. Most programs have directives followed by one or more sections.
Corrupt Converter says @spit_PV kernel is beyond the scope of what I'm aiming for here.
Racks. Didn't I just look that up? Where's my... I need to like organize my tabs better. Okay, I'm gonna move all the assembly stuff into on the right side of the screen so I can find stuff easier. Okay. This can go there too. this can go there. This can go here. But I think you said it was like register. Oh wow, okay, never mind. This does not show up.
Corrupt Converter says it's not about the language, it's about the level of problem solving and thinking necessary to do anything in the language.
Misty Mouse here.
Spit_PV says doing assembly without knowing what physical and logical RAM is, and what's Linux or an OS is inside, is a bit over the top info. You'll probably forget. Carl smile.
But what else could I be doing right now? Think about it, Spet. I could be playing some random video game. I could be playing Cookie Clicker, or I could be playing freaking Bejeweled. And what am I accomplishing? I'm not accomplishing anything, I'm just having fun, but there's nothing wrong with that either. If anything, I will get something out of this. Yeah, maybe there's more efficient ways to do things, but it's fun. And I have someone with me here, Corrupt, who's used assembly before, so it's a great opportunity for me to dive into assembly and see what I can get out of it. I don't really mind.
Corrupt Converter says you're missing the point.
Oh, I never thought it was an experiment.
It's about learning problem solving and critical thinking. Also, it's an experiment. I want to see if the results I got are just a one-off, or if it's actually viable.
Now I'm even more motivated to be successful.
Spit_PV says playing a game is well spent time, if you know what you're doing with your time. LUL.
Yeah, and I would be playing a game right now if I wasn't doing this. I'm just choosing to use all my free time to play games, to look into things like coding and math, and at my own pace. It's a casual study stream, just having, fun, getting some things done, combining those things. But yeah. What was I gonna look up? Okay, I have to stop getting so distracted. Where's my Google tab? Oh. Long size register. Did you say register's like the long-term memory? As opposed to... What was the other thing? Register versus what? I forgot its name. Register versus...
Corrupt Converter says registers are very short term.
Oh, they're the short-term ones. They change a lot. Got you. So this is a longer size register. Added in 2003 during the transition to 64-bit processors. Oh, and then EAX is the little one. 32-bit int size register. Okay. So you have RAX and then EAX. It's probably, the R probably, oh wait, no. I was gonna say the R probably stands for register, but there's no R in EAX. Okay. But what do you think, okay, one of my big questions that I have is, why do you think, okay, wait, where's the thing I was looking at? I think it's here. Yeah. Why do you think this Hello World? Why does this look so different from this Hello World? Shouldn't they be more similar to each other? Oh, .asm. Or is there just different ways to do the same thing in assembly? And they're just choosing different, they're choosing different ways to do it.
Corrupt Converter says, I feel like they simplified this one a lot.
It's just, yeah, okay, thank you. Because I was like, this is simplified. This has to be simplified. Because they're not doing all the move and all that other stuff. They're, okay.
Corrupt Converter says there's setup that's
Thank
supposed
you.
to happen that they must be doing on their end.
That's what I thought. They're hiding certain things that they're doing with the assembly. Because it's the Hello World exercise. They want it to be not too hard. Okay. Thank you. That should be nowhere near enough to print.
Converter says,
I know.
Yeah, that should be nowhere near enough to print
I was like,
anything out.
That's what was suspicious. I'm like, this is supposed to be more difficult than just print Hello World. That's essentially what they did. It's like print Hello World. Like, excuse me. It's assembly. And then I think what you said. Sorry, I need to review it again. LEA. Something with the load effective address. Did you say it was loading something?
Spit_PV says at Corrupt Converter it's not about problem solving in general, cause assembly is just docs about how computer tasks work, and yet if you CONCI to reading a lot of docs as critical thinking, I call it being a dev that searched a bit deeper in the abstraction levels. Pop Nemo.
Oops, I have to stop clicking on things. Hold on, sorry, give me a second. I'm just have to scroll up through the chat to find what you said to me earlier. For LEA. Where was that? There's like all this combo stuff. Wish I could Command F my chat. Control F, I guess. I'm not on Mac. LEA.
Corrupt Converter says knowing how
Loading
the
a memory
works
address
is pretty important.
Loading a memory
but by
address.
Problem solving, I especially mean breaking a problem into small parts.
Load effective address, loading the memory address. Okay. So we'll see. Maybe.
Says, anyway, IGTG for a bit for a shower.
Okay. I'll see you, Corrupt. I can do a little bit more of this when you come back. I'm gonna switch back to while you're showering. I'm gonna switch back to watching some of the videos I was watching from CS50. This is really interesting. Okay.
Called Scratch, and odds are some number of you used this probably as early as like middle school or the like, and that was fine to create your own art, animations, games, interactive art or the like, but we'll use it today for just a bit, and we'll use it in the courses for Explore, aka Problem Set Zero, to explore now some of these things today for just a bit, and it's fine to create your own art.
Going on assembly to learn stuff randomly without basic computer knowledge, but hey, it's my opinion about the subject.
Yeah, there's nothing wrong with having an opinion. I'm definitely gonna do leak code sometime. That's been on my my list for a while. Right now, I'm working through Exorcism, which is like there's a lot of places you can go to solve coding problems. Um, Exorcism has some like easier problems. They have a learning track, not for assembly obviously, but they have a learning track for like all the the main languages. So I'm at least gonna go through their learning track because they're just basically like super super easy leet code problems, and then maybe work through some of the regular problems, and then eventually, do some leet code. I like having problems. Like I like when they give you a problem to solve.
Spit_PV says if you like math and coding, just do leet code and you'll problem solve like a pro and find a job in no time.
Hopefully leet code will be helpful. I don't really like math, but I want to get better at it. That's why I'm doing it. So yeah, there's some other ones too. I definitely want to dabble in all of them. There's also like code kata. I think that's what they call them, like code kata, and what's the other? That's the only one I remember right now. And it's like leet code, except the community can submit problems. I don't know about leet code. Can the community submit problems, or is it just the people who own the website? I don't know.
Spit_PV says to work in Google they'll test you on leet code, not random assembly, no OLDGA, and even more if it's not your field.
Yeah, it's not about working for a company. It's about understanding the field of computer science as a whole, which consists of many different languages, and at the most basic level, often you get down to assembly. C becomes assembly, C++ becomes assembly. A lot of things, get lower level.
Spit_PV says then understand computers.
Yeah, I want to look into computers in the future. I want to look in all those domains, so there's nothing wrong with delving into different areas. If you want to really, really deeply understand computers, then you'll start to go into electrical engineering, which you also need a math background for that, but, all these things are connected. It's really cool.
Animations. Game of you used this probably as early as like middle school or the like, and that was fine to create your own animations, games, interactive art or the like. But we'll use it today for just a bit, and we'll use it in your own animations, games, interactive art or the like. But we'll use it today for just a bit, and we'll use it in the course's first homework, aka problem set 0, to explore now some of these same ideas. And among the goals today, for the remainder of today, is not to focus so much on Scratch and the particulars, because this is not a language that you're going to use often, but to give you very visual representations of ideas.
Oh, nice.
So that when things you're going to use often, but to give you very visual representations of ideas, so that when things do escalate next week to C, to the more cryptic, it's the same ideas, just typed out instead of dragged and dropped. So by that I mean this. I'm going to go ahead and share in just a moment the user interface of Scratch. But what's nice about Scratch is that this is how we're going to implement that same program today. These are 2 blocks, dragged and dropped. So by that I mean this. I'm going to go ahead and share in just a moment the user interface of Scratch. But what's nice about So by that I mean this.
Yeah, Uni's a cool place to be, because there's a lot of opportunities to explore on campus.
Says I do it as a hobby for now.
Nothing wrong with that.
I'm going to go ahead and share in just a moment the user interface of Scratch. But what's nice about Scratch is that this is how we're going to implement that same program today. These are 2 blocks or puzzle pieces on the screen, and they've been interconnected to tell the computer to say, hello world on the screen. The user interface that we're about to use will look generally something like this. It's a web-based editor that you can also download it locally to use offline, and you'll see that on the left here are a whole bunch of puzzle pieces or blocks. They're categorized by color, and the blue ones tend to relate to motion, for instance. The purple ones represent looks. The pink one represents sounds. The yellow one represents events. More on that soon. The orange ones represent control, and then there's operators, variables, my blocks, and even some extensions we can install as well. So it just categorizes things visually and colorfully so that you can sort of find what you're looking for. But we're going to use these puzzle pieces to drag and drop them onto this area here, and we're going to connect them when we want them to do something. What can they do? Well, by default, Scratch comes with this cat here, otherwise known as a sprite, which is a character in a game or in a graphics context. And this cat lives in this two-dimensional world in which the cat can go up, down, left, right, and you can actually change the cat's costume to be a dog or a bird or anything else. It really is more of an idea than it is a specific animal in this case. But the world that Scratch lives in looks a little something like this. It's like a Cartesian plane with x coordinates and y coordinates, and the numbers don't so much matter fundamentally, except that when you want the cat or any character to go up, down, left, or right by some amount, it's useful to know, for instance, that 0, 0 is the middle, 0, 0 for x, y. All the way up is a y value of 180. All the way down is negative 180. All the way to the left is negative 240. All the way to the right is 240. And generally, you're not going to have to worry about numbers. You're going to use these relatively, go right, go left, go up or down. But that's just the world that Scratch itself lives in here. So let's go about using Scratch here. I'm going to change over to my cloud-based editor here, where I've gone to scratch.mit.edu, and I've clicked Create in order to create a project. And that gives me this blank canvas here. And I'm going to do these somewhat quickly because I kind of know what I'm looking for. But part of the process with problem set 0 is just going to be clicking and dragging and sort of scrolling around to see what building blocks exist. But I know under Events, there's this puzzle piece here, when green flag clicked. Why is that germane? Well, if I zoom out and go back to Scratch's world at the right here, notice that above Scratch's world, there's a green flag, which is going to mean go, and a red stop sign, which of course is going to mean stop. So if I drag this puzzle piece anywhere into the middle, it's just going to plop where I put it. But what that means semantically is when someone clicks that green flag, I want Scratch, the cat, to do this other thing. Well, what do I want it to do? Well, let me go under Looks, and Looks here, in purple, have some puzzle pieces like this. Well, I can say hello for some number of seconds, or I can just go ahead and say hello. So let's do that. I'm going to drag this say block, and notice that as soon as I get close enough, it's going to sort of magnetically want to connect, so I can let go, and they snap together automatically because they're the right shape. I don't have to say hello exclamation point. I can change it to the more canonical hello, comma, world. So anything in this white oval is editable that you can change as just text there. If I now zoom out, let me go ahead and click the green flag, and voila, this should be my first program in Scratch.
Spit_PV says,
any of the distractions of syntax.
Here's some straightforward advice. If you want to make real progress in game design or game engine development, you need to focus on your goals and avoid getting sidetracked by random knowledge that you'll probably forget. I've been through that phase where you're just soaking up information for the sake of it, and let me tell you, it doesn't lead anywhere productive if you're not applying what you learn.
Well, once I stop making progress, then I can change course. But right now I am. And I am using what I get. I'm using it to make things.
Says the reality is,
so there's
if
not a
you're
problem
not actively
here.
using the knowledge you gain, it will fade away.
That's true though.
Learning
If you
new
don't
things
use
is
it.
great, but without practical application, it's just a fleeting distraction. Especially in fields like game design or engine development, where practical experience and hands-on skills are crucial, spending time on irrelevant information can be a waste.
That is definitely true. Always something to pay attention to. The important thing is paying attention to what you're getting out of it.
Spit_PV says concentrate on what's directly relevant to your goals and projects. Develop your skills by working on real tasks and projects that align with your ambitions. That's how you'll build expertise that sticks and makes a real difference in your work.
And there's a time and place for everything. You know? And when those times come, hopefully be ready to take advantage of it. But at this point, the most important thing is that I make progress. Not necessarily the fastest progress ever. It's important that I make progress and I stay motivated and I continue to enjoy what I'm doing. So if I don't have fun doing what I'm doing, I'm not going to do it. No, I'm not. No. I'm not.
TV says anyway, just an advice, cause you're a smart person, LUL.
See, that's the only piece of advice where you've been wrong this whole time. I'm actually not. Which is why I go on these it takes me a lot longer to do things. I take the long way, not always the shortest path. You know?
Or weird characters on the screen, it's just done.
Like, smart people just absorb things like sponges. They learn quickly. They're focused on what they want. You know, they get there very quickly. But, I don't know. Hopefully, whether fast or slow, I can just keep moving forward. And just see where things go, and hopefully in the future I'll be able to push myself even harder.
Spit_PV says, I know a lot of people, and people like you that likes knowledge are rare and really useful and demanded.
Aww.
Don't be hard on yourself.
That's too nice, but nah. I deserve it. I'm not gonna beat myself up too hard, but you know, yeah, I've definitely, my track record's not so good. So there's nothing that can't be changed. You know, you can't change the past. If I could go back in the past, I would have, you know, worked harder in school. I would have, you know, tried to join more clubs, meet smart people, and hang out with smart people, so that I could be, you know, constantly around other people who are constantly challenging me. I would have challenged myself, which is stuff that I didn't do, and that has a cost. But yeah, is what it is.
What I want it to do. All right, let me go ahead and click stop there, and let me make it a little more connected to what we discussed thus far. So this puzzle piece here, say hello to do. All right, first program in Scratch, hello world. Without any of the distractions of syntax or weird characters on the screen, it's just done what I want it to do. All right, let me go ahead and click stop there, and let me make it a little more connected to what we discussed thus far. So this
PV
puzzle piece
says,
here,
you can change a lot of things, just organize yourself and get serious with it.
It's definitely easier said than done. If I could have done that and just snapped my finger and been a different person, I would have just done that. You know, it's a gradual process, it's a journey. And that's kind of what all my streams represent, is this journey of going from somebody who just never studies at all, who just goofs off all the time in their free time, to someone who, like, spends time trying to do things that are difficult for them. So I'm more like a rock, not a sponge, but...
_PV says, I believe in you, little knowledge sponge. No. Carl, smile.
I was once talking with a viewer, and they were talking about memory palaces. I think you might know what those are. I think a lot of people do. But I was joking, and I was just like, yeah, I don't really have a memory palace. I don't use that. My palace is like, it looks like what happens after an apocalypse. So then they were like, oh, Fallout Palace. So now that's what I want to use now. My little knowledge sponge is more like a dried up, shriveled Fallout sponge.
That you can change shape. I don't have to say hello exclamation point. I can change it to more canonical hello comma world. I want to connect so I can let go and they snap together automatically because they're the right shape. I don't have to say hello exclamation point. I can change it to more canonical hello comma world. So anything in this white oval is editable that you can change as just text there. If I now zoom out, let me go ahead and click the green flag, and voila, this should be my first program in Scratch. Hello world. Without any of the distractions of syntax or weird characters on the screen, it's just done what I want it to do. All right, let me go ahead and click stop there, and let me make it a little more connected to what we discussed thus far. So this puzzle piece here, say hello world, represents what type of building block, using the vocabulary of today. So it's a function. So these purple blocks are functions, say hello world. And let me give you another piece of terminology. These white ovals that take textual input, in general, those are called parameters or arguments, and they customize the behavior of a function. So a parameter or an argument customizes, modifies the default behavior of a function, like in this case, say. Similarly, in the C code from earlier that we'll see next week, the printf function took a quoted phrase like hello world similarly as input, but more on that in the future. So how does this connect to what the mental model we presented earlier? Well, here's problem solving, as I described it earlier, inputs to outputs with algorithms or code in the middle. Well, what we've got here really is an input of hello world, the white oval. The function or algorithm that it's going into as input is the say block. And what is the output of using the say block, the say function? It's the visual effect of having the cat have a little speech bubble appear above its head saying hello world. So everything we do, in fact, can be mapped back to that very simple idea of inputs and outputs. Well, let's make it a little more interesting, though. That's a little boring to just say hello world all the time. Let me go ahead and drag this away, and if you just drag it to the left and let go, it gets automatically deleted. Let me go under sensing in light blue here, and you'll see there's a bunch of blocks, one of which is an ask block, an ask function, which is going to prompt the human, me, for some input. So let me go ahead and drag that over here, and it snaps together. I could change the question, but I'm okay with that question. We'll use what's your name, but notice that this block, ask, is a little special. It is not just going to display like a speech bubble on the screen, it's actually going to return a value. This is another term of art today and onward. A return value is some value that can be handed back to you conceptually from a function so you can do something with it.
I'm not that smart. I'm just a person who likes learning useful things and get a good, fun, and technical job to make good money and help myself and people I like. Pixel Bob.
Aww. That's an admirable desire.
Another term of art today and onward. A return value is some value that can be handed back to you conceptually from a function so that you can do something with it. It's as though the ask function asks someone for their name, writes it down on a piece of paper, and hands you the piece of paper. You can do anything now that you want with that name, and here is how you access the name in this special block called answer, which again, we'll start calling a return value. So if I want to say hello to someone specific, I'm going to do this. Let me zoom out. Let me go back to looks, and let me go back to say, and I'm going to change the say block here to hello, comma. And then I'm going to zoom out. Well, I need two inputs, I think. So, all right, I'm going to grab another say block, and I'm going to put it below. And
Oh. Whoever followed, thank you for following.
And I could just type David, but this is going to defeat the whole point of asking me for the name, and it will only work for me, so I don't want to do that. So let me go back to sensing, and notice the shape is important here. Even if it's not quite the same size, the shape matters, and I can actually drag this and change the input of this say function to be whatever that return value is. That piece of paper that has the person's name on it. And it grows to fill, but
Oh, okay, cool. You were gonna show me some of the code, right? Aha.
Spit_PV says you'll push my motivation down. I've sent you a Discord invite.
Huh, really, Svet?
But now we have a program that I think, when I click the green flag, watch, is going to prompt me, what's your name? And now I have room to type down here, so I'm going to type DAVID. I'm going to hit enter, and it should say, hello, David. Wait, Huh. Well, maybe maybe it was, didn't work? DAVID. Here we go. Hello, David. It's missing the hello, but I'm...
Well, that's interesting. Wait, before I continue, and then hear him, like, explain why, let me think about this. Why did it do that? Oh, I know what happened. It's because there's no wait, so it just executed the instructions so fast, I guess, that all you see is the last result, David. I think that's what he's gonna say.
Quite sure we have a hello right there. So what explains this bug or mistake? Yeah. Exactly. It's just put another way.
Says I don't like problem solving that much, but I like chill challenges. It's rewarding.
It's weird because I like problem solving sometimes. It's like sometimes I absolutely hate it and sometimes I like it. It's very contextual for me, and it depends on my mood. Like if I'm tired, then I don't want to problem solve. So it's kind of weird. It jumps around. If it's a problem, yeah, it just depends. It also depends on like my attitude towards the problem. If I feel like I'm not going to be able to complete it, then I just have no motivation to want to do the problem. But if I feel like it's hard, but it's possible for me to finish it, then it changes a lot for me. So a lot of it has to do with my mindset personally, which can vary depending on the day. Oh, nice. Corrupt, I see. What you sent.
Spit_PV says understandable.
Yeah. That's interesting that one is larger than the other. Corrupt. The first one better. Yeah, I mean, I kind of like how the second one's shorter. But I don't know. I don't know enough to decide which one I like better.
Spit_PV says accept my invite, I'll send you some useful material.
Mmm. Oh, they don't do the exact same thing. Okay. Looking at it, they do different things. Oh. Wait, what is this? What is this program? Is this Hello World? What is this? They're showing me. I should look up what NASM is. Oh, second prints out. Welcome to JDoodle. Okay. The sum of two numbers. Oh yeah, they're different. They do different things. Cool. You'll have to send another friend request, but I think this from JDoodle. I see, because you don't really use the AT&T one, right? So the first one, the Intel one's like your code. The second one is just JDoodle's default boilerplate stuff. Right. Oh. Oh, I thought you made it the first one. Hmm. Interesting.
My PC is just so darn fast that it did exactly what it was supposed to, but it said, hello, David, so fast that we didn't even see, we being the human, the slowest part of the puzzle, see the actual hello. So there's a few different ways to fix this. As you know, we could have it say hello for some number of seconds, so I could kind of do that. So let me do this. I can decouple these by just dragging and letting it go so that they're magnetically far apart. Let me go ahead and drag this one, say hello for 2 seconds. I'm going to change the grammar here to be hello, comma, again. I'm going to go ahead and
says,
disconnect these two.
Second friend request still waiting, Kappa.
Okay, I saw it.
I'm going to change the grammar here to be hello, comma, again. I'm going to go ahead and disconnect these two. I'm going to throw away.
Converter says Kappa.
Kappa. Okay, I love that emote. It's funny. Kappa. What? Oh! But you wrote Kappa equals flying? What?
The old one that I don't want to use, and I'm going to go ahead and disconnect these two. I'm going to throw away the old one that I don't want to use, and I'm going to reconnect this so that now, okay, it's going to say hello for 2 seconds, and then my name, hopefully. So let me click stop and start. DAVID, enter. Okay, so it's better, but it's kind of like poorly implemented. Like, come on, I just wanted to say hello, comma, David. Why is that hard? Well, maybe we can actually combine these a little differently. And let me propose this. Let me actually get rid of these blocks again. And let me go ahead and just say one thing. But can I somehow combine this to say hello, comma, David, all in one breath? Well, it turns out if I go under operators, I know from having played with this before that there's this puzzle piece down here called join. And it's a circle, or it's an oval. It's a little big, but again, it will grow to fill. And by default, it wants to join 2 words, apple and banana. But whoops, but those are just placeholders. So let me go ahead and drag this over the default hello. let me change apple to hello, comma, space, and then banana, let me go back to sensing, let me grab answer, and drag and drop that. So now notice that I'm kind of layering my ideas. And put another way, the output of this join block is presumably going to join two things together, apple and banana, or hello, comma, David. And then the output of join is going to become the input to say. So aesthetically, it just looks better. It's still correct, but it's just better. So if I type David and enter, hello, David. This is what a normal program would presumably do, not show you part of the phrase and then the rest of the phrase. Like, it's just better in this way. So let's connect this now to this same puzzle piece in this methodology. So here's that same puzzle piece. Ask, how do we fit it into this input and output flow with algorithms? Well, the input to that puzzle piece is something like, what's your name? Question mark. Then the algorithm or the code implementation thereof is this ask block, and wait, so the human has a moment to type their response in. The output of that function, recall, is a return value. You don't see anything on the screen by default because we've not used say yet, but we get this return value. And let me scooch everything over now so that we can now join those on the screen by default because we've not used say yet, but we get this return value. And let me scooch everything of that function, recall, is a return value. You don't see anything on the screen by default because we've not used say yet, but we get this return value. And
Oh, okay. I just like, it's not even important. It's like so fast, like some of the random words are hard to hear.
let me scooch everything over now
Doesn't matter.
so that we can now join those inputs together. So here's this puzzle piece. Let me go ahead and propose that the inputs now to the
Spit
join block are
underscore
two.
PV says.
Was return value, yeah. He said he was saying what I couldn't hear because he was speaking fast because of the speed I'm playing the video at. He said we're not going to use say yet, but it sounded like not going to say yet. I'm like, what? But yeah, that's really all that matters. Ask something, put something in, gives you a return value. Classic function. TTS specifically only reads.
Spit
It's only for
underscore PV
English.
says TTS don't work with Arabic, not funny pop Nemo.
It's free TTS. So like you can have more languages if you pay for it, but I'm not gonna do that.
So that we can now join those inputs together. So here's this puzzle piece. Let me go ahead and propose that the inputs now to the join block are two arguments, or two parameters, so to speak. Hello and answer. They go into that
Spit
join puzzle piece whose
underscore
purpose in life
PV
is to
says
return.
open TTS.
No. Free TTS for streamers.
Two arguments, or two parameters, so to speak. Hello and answer. They go into that join puzzle piece whose purpose in life is to return one joined version thereof. Let me slide this all over logically now so that now that output becomes the input to the say block, and now is why the cat has the speech bubble. Let me slide this all over and
What did you say
answer.
there?
They go in to that join puzzle piece whose purpose in life is to return one joined version thereof. Let me slide this all over logically now so that now that output becomes the input to the say block, and now is why the cat has the speech bubble saying all at once, hello, comma, David. So what we've done here is kind of compose the outputs and from one function into the input.
By the way, the only thing I'm not gonna do here, I'm watching the lecture like quickly, but the only thing I'm not gonna do is I don't think I'm gonna do the assignment because you're supposed to use Scratch, but I don't think I'm gonna do this one for week 0. Once it gets to C, then I'll start doing them. What even is, wait, problem set 0. Where is it? Oh, all it is downloading Chrome? Oh, no, it's this one. Yeah, I'm just gonna skip the Scratch part. That's fine. What is this? Record a 1 to 2 minute video of yourself saying hello? No. Yeah, I can skip all that.
Of another, and you can think of this in a couple, comma, David. So what we've done here is kind of compose the outputs and from one function into the input of another, and you can think of this in a couple of different ways, left to right as I did there. We're kind of like stacking these things on top of one another. But at the end of the day, even as programming gets more and more powerful for us, it's just inputs and outputs, inputs and outputs. And thankfully, with built-in functionality from our friends at MIT who designed Scratch, I can even do something playful like this. I can go to that extensions button at the bottom, and there's a lot of fancy things I can add here, like text to speech. So let me go ahead and choose text to speech, and let me go ahead here and change the say block in purple. Let me get rid of the say block, and let me borrow this. Let me get the speak block, like this. And now let me drag and drop this oval. It's going to grow to fill, and I think it's just about to be a little more interesting. Let me click play now, and hopefully this isn't too loud. D-A-V-I-D, enter.
Hello, David.
Okay, yeah. Thank you.
And when does this part end? I think at like 1:30ish.
Thank you. That's a low bar. Let me go ahead and set the voice too, and you might. Okay, yeah. Thank you. Thank you. It's a low bar. Let me go ahead and set the voice too, and you might now remember how we began.
Yeah, why did they clap for
Corrupt
this?
Converter says you consent to the use of your 1 to 2 minute video of you saying hello.
I
the
did
purposes
not.
of creating a deep fake of your likeness to impersonate your image on the internet.
Oh god. Definitely did not. Oh my god. Even if it was Harvard, I'd be like, no, Harvard, I did not consent to that.
Class where we had a robotic computerized voice. Well, we didn't use Scratch at the time, but we could change this in Scratch alone to be a little different.
Corrupt
So DADID,
Converter says by viewing this text, you consent.
Dude, that's what companies are like. They're like, oh, you see this, therefore you consent. It's like, what the? No. That's where lying comes in. I don't know how to read English, Corrupt. So, oh wait, I don't know how to view text. I'm blind. I didn't view anything.
Thank you. It's a low bar. Enter.
Hello, David.
Okay. Thank you. Thank you. It's a low bar. Let me go ahead and set the voice too, and you might now remember how we began.
Bro, imagine if every time I coded something, even the most stupid thing, like I code hello world, and an audience claps for me every single time. Like, wow. Bro. Amazing.
Class where we had a robotic computerized voice. Well, we didn't use Scratch at the time, but we could change this in Scratch alone to be a little different. So DADID.
Hello, David.
Okay, a little creepy, but we can play all day long with that. But the point is that these functions are just now doing something a little different, but it's just these inputs and outputs. Well, let's make the cat more like a cat. Let me go ahead and throw away all of this asking questions stuff.
Okay, I just made it to the second section, so I'll stop here and math. Sorry, not this one. Let me move this down. Where's the one I was doing? Here. This one.
Corrupt Converter says imagine it was an audience outside your house looking through your windows waiting for you to complete the task.
Oh my god. That's like Welcome to the Game 3. Hell no, I don't want that. Oh my god. And then if you like get it wrong, what, they like break into your house? Like the amount of pressure I'd be under? Just a math category. You die? Well, I would be
Corrupt
dead.
Converter says you die.
Speed run death. I'd be dead in less than an hour. Engineering contests. The participants were divided into groups of 10. Three times many bucks. So 5,800. There's times as many bucks. So 50. Oh, I remember. Estimate. It's 30. 1,800. 15, 8, 16, 24. 50, 60, 74. Wait, how are they rounding this? Are they rounding it to 6,000 instead? So 6,030? Yeah. I think. Right, 30. Then 1, 2, 3, 4. 6. I think.
Beeftex _ says cheap viewers on coloradokSambung.com/Z9G9.
Jesus. Can't have a stream without having one of those show up every single time. 47 ducks swimming in a pond. Dog jumped into the pond, scare 29, but thank God for Siribot. After the dog got out, 5 groups of 3 ducks returned to the pond.
Corrupt Converter says cool free money, click that link.
I know, so that I can have as much money as you got from all the Steam gift cards, right? I still got 5 groups of 3 ducks. Okay, so I think 78 divided by 40? Or maybe 8. 8,000 divided by 40. So 2,000. Damn it. Wait, I did it. Never mind. 200. Because we're not multiplying, we're dividing. Meh.
Corrupt Converter says, why would it be 2000?
I know, right? I don't know. Because I was counting the zeros as if I was multiplying it. I did the division, like, oh, 4, 8 divided by 4 is 2. But then I counted the zeros, like, as if I was going to multiply that. But that doesn't make sense. You're right. Because 42 doesn't go into that 2,000 times. Yeah, that doesn't make any sense at all, actually. Just my
Corrupt
cheap
Converter says, well, it's guaranteed less than 1000.
Yeah, it is. I didn't check my answer for reasonability. That's why it would not be 2,000. God, okay. This is 1, 8, 10, 11, 18, 3. 381080. Wait, can I remember? I don't think I can remember that. 381080. Okay, it's just like welcome to the game. 381080. Yeah, and I have to use this freaking standard algorithm.
Corrupt Converter says, I wonder if addition like this is easier to do left to right or right to left.
Oh. Left to right or right to left? Huh. I don't know. I'm not even sure what that looks like exactly. 6 times 8 is 48.
Corrupt Converter says, I feel like I always do it left to right, but that's probably not generally easy.
8, 1, 8, 8, 2. Oh wait, you do it. Let me see. You do it left to right. You mean like... Oh. Oh, you mean like which part I start on? Oh. That's interesting. One time. Okay, so 100.
Corrupt Converter says RTL makes more sense than LTR, but I don't know.
9. Yeah, I think so. So you can carry over, numbers to the next column. But then you could just do it, you could still do it left to right, but then you would have to, like, go back. It would make you, like, move backwards. So, like, move the number over. Like, you'd have to, like, reverse direction. Wait, I don't know. If it was, like, really long, then it would be... Huh. I don't know. Like this 5,000 divided by 20. I think. Oh wait, let me think about this, because I don't want to get this one wrong. I think I got this, like, the one last time I got wrong. But it had different numbers. It was 20. Wait, but that doesn't go in nicely. But I can still reason it, I guess. Because 20 goes into 105 times.
Corrupt Converter says.
50 would be 1,000 times 5. I think it's 250, right? Because... Wait a second. No, wait, no. Yeah,
Corrupt
250.
Converter says 250
Yeah.
at a glance.
Yeah, I'm down. I'm down to VC. I do have to go at like 40 minutes from now. But yeah, we can VC if you're down. I don't mind. It's fun talking to you. 250 at a glance. Wait, what the heck? Why is... Dude, this stream, the one that I'm streaming to YouTube, it's streaming the CS50 video. Like, I'm doing math, and it's streaming something different. Maybe it has like a major delay. I don't know what's happening. I don't know why it's streaming that. I'm not streaming that.
Spit_PV says, do you want some game dev books? I have a lot of them.
Oh, I know what it is. Oh, really? Oh my god, really? Really, Spit? That'd be so cool! Giga delay. No, it was my fault. I was just scrolled back in the stream. That's what happened.
Spit_PV says,
because that would be a crazy delay. But, yeah. Oh my god, it'd be so cool. I want to learn everything about game dev. All the things. Anytime I find a resource related to like game dev, or I find a resource related to game theory, I immediately bookmark it. I'm like, yes. More things for my collection to look at. Yeah. Oh, okay. I'm gonna go join you.
Says, wait, what? Giggle delay.
Giggle delay. No, there was no delay. It was skill error on my part. There was no delay. It's fine.
Corrupt Converter says giga delay.
Giga delay. Alright.
Corrupt Converter says giga delay.
Giga. I like GIF and GIF. Oh, it said Giga? I didn't even realize Giga. Oh wait, I didn't mean to pin that. Aww.
Spit_PV says, okay, wait a sec, I have some expensive books on game dev. I'll send you a fat zip on everything you need.
Dang. Have you made some games before, Spet? Let's hear it. Giga delay?
Corrupt Converter says giga delay.
Wow, it does say that. Giga delay. That's funny. Yo, sup, Corrupt. Your name is Corrupt, not Corrupted. What, hello?
Yes, I'm like that.
You're not dead, that's good. You're so quiet. Like I can barely hear you at all. Or maybe... Oh, I'm gonna turn my I just need to turn my volume up, that's why.
You know, maybe that could be something, or...
That's it. I just had my desktop audio really low.
I'll give me a second.
Okay. Alright. Oh yeah, 390. Oh wait, no, they want. Never mind. I thought this was another estimate
PV
question.
says, yeah, I made some light tests on Godot and with Pygames, and finished yesterday a little game for Discord.
Oh, cool. Oh, wait. Are you the person who said you use... oh, wait, no, sorry. I'm thinking... Never mind. I don't remember who. I only saw them one time. There was someone who came into my chat who programs with Go, which is different than Godot, but I just remembered them. Like, I've never met anyone who programs in Go before. But I found out that's related to, like, systems design or something. I don't know. Like, that's what it's used to program. 365.
I don't know if you can see what Go code looks like.
What did you say now?
I haven't even really seen what Goku looks like. I've never really looked into it.
Oh, yeah, I have no idea. I just know that the mascot looks like kind of cheap, like lower quality than AI art. Oh, you Godot. We're talking about Godot, not Go.
Says Godot, it uses script which close to Python and nothing to do with Go.
Yeah, they have nothing to do with each other. But I heard you say Go, and then I just heard Godot, this TTS, and then I remembered that guy.
Doesn't Godot also support like C#?
It does now.
Does now?
Yep. And apparently, I think it's like, yeah, it supports C# now. Now it does. But it used to just be GD script.
What about when the whole Unity thing went down? I thought it also, or at least semi-supported C# at that time.
It did semi-support it, yeah, because I remember when that whole Unity thing went down, I also looked into Godot as well. And
He
I
probably,
looked into...
he probably went like, let's get this thing done like as quickly as possible when the whole Unity thing went down. Like, we gotta get C#.
Yeah, they saw the opportunity. They're like, this is the perfect opportunity to get people to use our engine.
Like, oh, it's time for C#.
C# time. For sure. That's the smart thing to do. 1011. 4, 6, 6 minus, what is this? 2. 4. 4. 2. 0. Okay. I'm gonna double check this quickly on my calculator because I don't want to restart from the beginning. I hate when I have to restart from the beginning. It annoys me so much. So much. So much. 3, 6, 5. Dang. I wish. Oh wait, I'm wrong apparently, or I did the calculator wrong. One of the two. I'm probably wrong.
Yeah, this one I do from left to right.
5. Yeah.
Did you do it from left to right or right to left?
Right to left. You do left to right this too? Holy.
Yeah, I do left to right. Like this one, I feel like would be easier to do left to right.
That's interesting. Wait, so I had. Maybe did I write the numbers right? 3, 6, 5, 2, 5. Okay, my 2's ugly. 3, 8, 9, 1, 1, 6. So I had the. This was a 0. Oh, I thought this was a 6. Wait, 11 minus 5. So 6. 0 minus. Oh! I thought it was. My 0 looked like a 6, so I got confused. Because my handwriting is absolute trash.
Spit_PV says just use mental math. https://www.youtube.com/watch?b=1jw9b857ara.
23, 460. Wait, no, 8. 860, because I rewrote the 8. Because 10 minus 2 is 8, yeah. 23, 860. This is what I check with the calculator. Yeah, there's ways to do this mentally, too. But sometimes I just, like, even if I'm doing it, working out mentally, if I'm not taking notes at least, like, I forget because I can only have 2 items in my working memory at a time. I think the average human can hold, like, 4 or 5 things in their working memory. I hold, like, 2 before I forget what I'm, like, what we're talking about.
Like 20. Get the number up to 20 easy.
Get the number up to 20? Think about all the conversations we've had, Corrupt, where I'm just, like, talking. I'm like, wait, what are we talking about again? And you're like, oh, here we go again. 2.
I don't think I've ever said that.
You didn't. You've never said that, but I'm sure that's what you've thought. Whenever I just am randomly. Oh, well, you're too nice. Well, then maybe you were just thinking, get good, or don't, or oh my god, I ran out of space. Oh,
Or, you know, just thinking this is what working with old people is.
Oh wait, this is estimate. This is dumb. I don't need this. I have to read the instructions. Wait, what were you saying? Sorry.
I said, or I'm thinking, well, that's just the experience working with old people.
Oh wait, that's worse. You're so. Oh my god. You're so rude. Oh my god, when you called me Joe Biden's wife, I was like, oh, husband. You called me Joe Biden's husband. I cried inside a little.
I didn't do that.
They did.
I said he called himself Joe Biden's husband.
Oh. So I can't even remember that.
Well, Biden
But
said,
he
"Hey,
did.
I'm
Yeah, he
Joe
did.
Biden's husband."
Yeah, he
That's
did
what I
say
was
that.
saying. I mean,
But then
well,
afterwards,
do
I
you
think
want
you
to
were
be Joe
like,
Biden's
you could
husband?
be like Joe Biden's husband or something. But yeah, he did. Yeah, he did say that. He also
Are you
said
Joe
that.
Biden's husband?
No,
Do you want to be Joe Biden's husband?
no. Wait,
Do you want to be Joe Biden's wife's husband?
wife's husband? No.
Well, now that you said that, I'm just gonna assume that you look like Joe Biden.
Wow. Sniff.
What?
I said sniff. I'm sad. Joe Biden has kind of a creepy smile. I saw a picture of him that wasn't Photoshop.
He's got that dementia smile.
God. 5, 6. Wait, why am I doing it like this? Wait, what are they rounding to? Probably 5:30. Wait, why am I doing? Oh my God! See, I'm not like paying attention. I can't multitask. This is like 5:30 plus 250. That's what they're doing. 700 and then 50 plus 25. 75. 2 large ant colonies.
Spit_PV
Kill them.
says Joe Biden discussions.
Joe Biden discussions.
Look at this score.
What? On Discord. Bo Jiden. You forgot. You should spell it with a G.
Yeah,
You should spell it with a G because remember the TTS pronounces all the G's with a J.
He got a facelift, as you can see.
Spit_PV says
Ah.
I like Cotton Eye Joe for my part. Carl smile.
Dude, when I was a kid, they would play that song all the time. It was so freaking annoying. I hate that song. It was like, I don't know. They spammed the hell out of that song.
Yeah, that, and
They did it for you too? No way. That song never went away.
And there's another song.
Hamster Dance? I hope it's
I
not
don't,
that.
I don't remember. I don't remember what it's. I don't know what it's called.
Is it the
It's one,
hamster?
it's one that you're supposed to dance along with. It's got a bunch of instructions.
Oh, Electric Slide. It's like slide to the left.
Yeah, that one.
Take it back now. I hate that song too. God damn it. It annoys me. And then during
I'm pretty sure we had to, in dance class in elementary school, we had to do that at least like 100 times.
I feel so sad for you.
PV says Cotton Eye Joe mental trauma.
Actually, mental trauma. I feel so sad for you though. You had to go through that. Oof. Yuck. Ew, they made you take dance though? Yuck.
Yeah, dance and music class.
Wow. In music class, there was no
Yeah, we
dancing.
learned how to play
Recorder?
On a flute, yeah.
Yeah, recorder.
A recorder, yeah, probably
Mhm.
that.
It's the stupid plastic flute that sounds terrible. Love that.
Yeah.
Recorders are such a meme.
Should have made us do Rush E on a whistle.
Actually, maybe it would be fun to do like Rushy even on a recorder. Rushy's kind of sick.
Play Rushy completely on piano.
Handsome.
Like not missing a single note.
Where are you? Plus 390. I think 400. Wait, 3. How do they want me to round? I wonder what they want me to round it to. 400? I'll try that.
It's
4.
completely illegal to run this experiment, but I wonder
590.
what it would be like. Wonder what it would be like if my whole like elementary school was basically like military basic training.
Would you have enjoyed that more, do you think?
I just wonder how I would be today.
Oh,
How that was.
I don't know.
Like I said, it's probably completely illegal to run that kind of experiment.
Yeah, unethical. But I will say, during the periods of my life where I was most rebellious, if you had put me like under more discipline, I would have rebelled harder. I would have made it much worse for me personally. So
I should show you some of those videos at some point. Like this video is gonna show you a little bit of like what I'm gonna go through when I go to the meeting. Speaking of, things are looking a little more likely to work out in that
okay, congrats! That's awesome. You've been working really hard for this, you know? Like getting
Spit
all your stuff in
underscore
order.
PV says, how old are you on this screen? You are not obliged to respond to this question, Pixel Bob.
Oh, don't worry. I know I'm not obliged. Right, Corrupt. Right, Corrupt. The the amount of times Corrupt has tried to trick me into giving it's pretty funny. It's funny. But we've come to the agreement, Corrupt and I, that you know I went to school with Aristotle. But he bullied me. We didn't get along very well. But I'm old enough to be every single person's great grandmother who's alive right now on Earth.
Basically, they're old.
The oldest. But I'm not the wisest. That's the sad part.
Realistically, that's why I'm in the 4th grade.
No, I was supposed to be in 7th, but then I forgot there were all these other curriculums I
Yeah,
had
but
to
then they bumped
finish.
you back down when they looked at.
That's not what happened. I just didn't see there was another link that said list, like
Yeah,
see
I didn't
all
know.
math.
Like I said,
I didn't
I
know.
didn't know that's exactly why you get knocked down, because you didn't know. You didn't know enough to be where you were.
Damn. It hurts. Okay, I think you do
I
want to
didn't
do
know,
like
aka I
this.
was too stupid to know.
Oh, I didn't know. I didn't
Spit
know.
underscore PV
44.
says, okay, you're close to 30 or below, Pixel Bob.
Nope, I am 44. 1, 3. I hope I didn't screw this up. Did I screw
I'll
this
have to
up?
narrow it down by asking yes or no questions, right?
You think I'm gonna respond to your yes or no questions, silly? 44 times 9.
Yeah, just ask some really invasive questions, right?
Okay. Wait, what did I write here? Is that a 1 and a 1? Yeah, 1.
0.
No, 1.
It's
Did
0.
I? Wait a second. So 9. Oh, well, yeah, I just need 410. Run through 96. I can just do that mentally. So plus 4, 400, 14.
Spit underscore PV says, it's just a guess now, it's not a trap.
14. 8. 4843. Wait, what? 119.
Yeah, I think that guess is probably pretty close.
119. What if I was like a 100-year-old using a voice changer so I don't sound like a grandma? Just saying. Did you think about that?
I think.
Didn't you once ask if I was a dude? You were like, "Are you a dude?" I'm like, "Am I?"
That was probably for.
Am I?
That was probably. So the thing is, when I do that kind of question, like especially after hearing your voice, it's usually like depending on your response, dictates the next joke that I make.
Spit underscore PV says, what if you was an AI?
I did bring that up.
Are you Neurosama?
But the thing is, definitely not an AI. An AI wouldn't say that, but I'm definitely not an AI because
Someone tell Beagle there's a problem with my AI.
if I was an AI, I would be significantly smarter. Like, I know ChatGPT likes to hallucinate.
Well,
I know ChatGPT likes to hallucinate all the
that's not
time,
necessarily, A does not equal B there, right?
Yes, it does.
Just because
when you have my level
you're
of mental
AI,
competence,
you're an alleged AI.
There's
does not imply that you are smarter.
You said you gave me instructions when we were doing that math thing. Remember, you said instructions. You said draw from the left to the top, like, and I was like going from the right, and you're like, no, from the left to the top, and then I was like drawing from the right. No,
the left of the bottom line.
The left
so
of the. And it was like
up, and then you went down.
Oh, you said up, and then I went down, and it's like, there's no way.
You know, you followed, like, technically one of those instructions you followed correctly,
Oh,
but the other one you followed absolutely wrongly.
Okay.
You know,
Hey,
you didn't draw a line up.
Wait, so I am smart because I did follow one of the instructions correctly. That's actually yay.
No, no,
Yes,
no.
yes. Haha.
You failed the other instruction. That's called being stupid. It balances. It
So
at least
funny.
cancels out
What is
to zero brain. You don't have positive or negative brain. It at least cancels out to zero.
Okay. Okay. To zero.
1 plus negative 1
It could be
is equal
worse.
to the amount of wrinkles on your brain.
Yeah, it could be worse because actually I'm very smooth brain. Wow. Inside.
Inside and outside.
Well, brains are inside, so they're not supposed to be outside. But you know what? If I could have a second brain on the outside, it
On
would.
the outside if you really wanted to.
I guess. How many times do I have to hit my head with a calculus textbook to have that happen?
8?
8?
Probably manage it with 8.
Oh my god. Oh, I did this wrong, by the way, so I have to do it again now.
I mean, first things first, if you just destroy the skull, then, you can probably just pull the brain out. That's probably how it works.
Oh, this should be a 4. I think that's the problem. I'm gonna try again. So 4. There should be 149. 4. Wait, no, it's still wrong, actually. Wait, maybe there shouldn't be. Maybe it's just 14. There's no 9 there. Yeah, there's no 9 there anyway. It's 14. What do you wait a minute?
So I'm assuming they're using latex to write this. I think.
What do you think? You're not allowed to
think.
think.
That division symbol,
I'm wrong
I
again.
think
Damn
what
it.
they're doing to make that division symbol is literally
Yeah,
just a
a parenthesis.
and an overbar.
You didn't realize that? That that's what they were doing? I realized it the whole time. It's just
The
right.
underscore PV says look in your DMs.
Oh, okay,
What
it's
I'm
just
wondering is
parenthesis.
if there is actually a thing in latex for doing that division bar.
Oh,
Or
probably.
That division symbol.
Yeah.
Maybe there is, but I
They did
also
it
have
the
no idea what it's called.
lazy
so I don't know how to
way.
look it up. I don't know how to look it up because I don't know what it's called. But I like that they just use a parentheses and an overline to do that. It's just like, well, you kind of get the shape. Kind of works.
Yeah, kind of works. But yeah, it does kind of look. It's a little jarring if you like look closely enough. But here, look, I fixed it. See, it looks even better now because it's connected.
No.
No. No.
No.
No. No is not an answer.
They're not
Accept
straight
that.
lines. It's not even straight lines anymore.
But it's more connected. It looks more homogeneous.
No, but now they're like, no, you fix one problem and then you create 37 other problems.
Hey, just like I do when I program. Right? It's perfect. 5, 4, 3. What did I? Why can't I do long division?
Yeah, you just gotta get better at programming so you don't do that.
Okay. Oh wait, this should be
every
140.
time you run your code and it doesn't work, you get a massive electric shock through your body. Like we should do that thing where you have like a shock collar or something.
Oh my
every time
god.
your code fails to do what it's supposed to do, you get shocked.
I don't think that'd be
And each
effective.
successive time the shock gets worse. The shock gets worse.
Wow. 40.
You gotta do level 1 shock on the first time you make a mistake, then level 2 on the second time.
This should have been 0. Okay, I need to like erase a lot of things because I messed up.
Yeah,
Oh, I didn't want to delete
You
that.
have a lot of incentive. If it gets too high, then you die.
Oh,
So,
why
you
can't I
continue to do it.
just set it up? Just max it already, and my suffering, so that I can get, so I can finish on the first.
Just set it up to
Question to
whatever
get
the
wrong.
maximum. Just limit it to whatever the maximum is. Why don't we just set it there by default?
It's basically the electric chair. That's what that is. Except
Now where should we put it? On your neck, on your skull, on your leg?
no, whichever place is more lethal.
Neck is pretty bad.
Is it?
I mean, I feel like if you put
4.
it inside of your body, it's probably a little bit more dangerous.
Maybe.
Like,
I think skin is actually an insulator. So skin.
Yeah. Swallow the shock collar, or something like
Okay.
that, or stick it in
3.
some other way, and then shock, and then see if it hurts more or less. It might hurt less.
Why am I wrong?
Well,
I can't do freaking long division, I guess. Wait, because 14 times 4 isn't anywhere near 4,483. Wow, I completely forgot how to do long division.
1.
I forgot how you do it, like, the long way. Well, okay, I need to think.
Remainder 3? Wait, what?
Because you...
1,
4...
1, 0, remainder 3.
Wait, wouldn't it... Oh, yeah, you have to bring down a 3, okay. Yeah, but... But this isn't... This is wrong.
1, 1, 0, remainder 3.
Oh,
4,
1,
8,
1.
4, 3 divided by... I'm reading this right. 4, 8, 4, 3 divided by 44.
Yes. Wait
1, 1, 0, remainder. I feel like it's just 1, 1, 0, remainder 3.
Oh, you're probably right. But, like, what... I don't know what I'm doing. What am I doing wrong here?
Like on the first one, 48 minus 44 is 4. Then you have 44 minus 44 is 0. So that gives you 1 and 1. Then you have 3 left over, remainder 3. 1, 1, 0, remainder 3.
1... Wait, but where's the second one coming from? Because it was in once, and it's 44.
48 minus 44 gives you 4, which is no longer divisible by 4, so move on to the next digit. That gives you 1 in the hundreds place. Next,
Oh yeah, there are 2
44
ones.
Minus 44 gives you,
You're right.
0, but gives you 1 in the tens place. And 3 not divisible by 44, and not divisible by 44.
I see.
So then you get.
See, this is... Here's the real problem. I was stuck on this for so long. Like, look at this. I can't read what this is because I wrote this, but it's so messed up. It just looks like a bunch of lines like this. That's my fault.
So I feel like one of the problems with that long division thing is that you're not writing all the digits the whole way. I don't think about, like, you have 44. Like you have 44 there, and then 44 and 44. I think about it like I do kind of keep all the digits like in my like sort of in thought when I'm doing it. So that way then I don't run into that problem that you have down there where you have a 30 for some reason.
Yeah, I just...
That
Well, that should be... It should be a 3. There's no breakdown.
Yeah, there shouldn't be a 30. It should just be 3.
It's just 3, yeah.
And that should
I accidentally brought down a
110,
0.
110 remainder 3.
Yeah. 110 remainder 3. Right, so... Do they want 7...
Well, just see. Like, none of the other ones are, like, anywhere near.
That's true. I could also do elimination, but... Yeah, that would be quicker and easier. I want to do it the slightly more difficult way. With estimating, because it's supposed to be, like, estimate, so I just want to, like, round it off. Each car's 4 tires used to resolve the kind of car.
23 times 4 plus 2.
By the way, how's your day been?
About 100. How's my day been?
Oh, for a second I thought your day was about 100. I'm like, oh my god, it's a perfect day for you. If you're scoring at 100, like, never mind.
Well, I found maximum is 99 on the SRAT. I got yeah, I mean, there's some good news with the marine stuff.
Yeah,
so
that's great.
The best thing that happened today.
Hell yeah.
But I don't. But I mean, I say that, but I don't actually know if it's good news yet. But part of it is that I thought I needed 2 proofs of residency. I only need 1 because the ID that I need 2 proofs of residency for, I don't need at the moment.
Yeah.
And I can get it later on when I have more documents that will be valid for that. But I don't need it right now. They'll apparently issue me something that'll solve all my problems.
Got you. But that's great, though. Sounds like good news to me. Cars.
I feel like this is
22.
This is 100.
I bet it's gonna be 100.
This looks like 100. Like, it's not.
Oh, he has
250.
22 right now.
I'm pretty sure it's less than 100, but like between 100 and 54, it's closer to 100. Like, the way I do this,
because it's multiplying by...
Yeah.
So you have 80, and then 16, 24, 32, plus 32. 112? Minus 22?
Well,
Wait, estimate. Oh, I'm dumb.
Yeah.
Okay, never mind.
yeah, you don't calculate this exactly, just estimate. I mean, closest thing is 100.
7, 8, 9. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 12. 120 divided by 20, right? So.
But minus
Wait.
22.
Oh, he has 22 tires right now. What am I doing?
Minus 22.
Yeah. 100. You're right. Minus 20. Not. I don't know why I multiplied. Right. 1, 2, 3 tennis balls. Where should I get confused my head? Number of tennis balls. Oh my god. Once I have to go, I don't have to go yet, but it's slowly approaching. Like I have about a half hour right now, but I'll be back. Once I'm gone, I'm gonna leave for like an hour, and I'm gonna come back. I don't know if you'll be around, but I hope you will.
It's 9 o'clock right now. I'll be around for a
Yay!
another, like, because thanks to you, I'll probably be around for the next 7 hours.
No! No. I still feel bad. I was actually happy we went to bed last night, because I was like, oh, finally you're getting more sleep. Some more sleep. That's good.
Yeah, fun story about that is I woke up for a good while at 7 o'clock.
Oh god.
I couldn't even sleep the whole way through.
Aww. Actually, I woke up a lot earlier too.
And I went to sleep that early because I was getting a pretty significant headache. So
Oh.
it wasn't even comfortable sleep.
I see. I'm sorry.
I don't know what exactly was causing the headache, but, you know, it is what it is.
Yeah. Well, for me, I get headaches when I'm like, oh, I know. You were staying up so late the past few days. Like that actually will give me a headache if I'm constantly staying up late and sleeping a lot later than usual. After a few days of that, it'll trigger a headache or laying in a weird position.
Well, for me right now, my sleep schedule is just shifted by a good couple of hours. So it's not like I'm really getting less sleep. It's just that I'm getting sleep at a different time.
Gotcha. Yeah, but even
like
if
my hard limit for when I wake up is like around 11, 12, or 1.
Oh, okay.
But like when I slept at like a more normal time, I'd wake up around like 7. So now I'm sleeping a couple hours later, I'm waking up.
What have I done? I'm sorry.
Well, I mean, it's like, I don't have a job right now, so I don't need to be up at specific times, except for things like around the house.
Yeah, I see. Got you. But it has been really fun. I've had like a ton of fun, so thank you. Wait, Jennifer 5-2s, 1 ball left over. It's funny because like sometimes questions aren't very hard, but I don't know why. But whenever I just see a number show up, it just makes me like throw away.
First things first is it's like solid red. You need N on one side of the equal sign with nothing else next to it, so you can immediately rule out A.
Because we want N the number of tennis balls. That's right.
Like there's multiplication involved, so it's not C because C is only addition.
Yeah, one.
So it's just B.
Well, if I made the thing, like and rearranged for N, 3 tennis balls.
3 tennis balls, and they filled 5 too.
So 3 times 5.
5 times 5. 5 times 3. I mean, yeah. And plus 1, which is.
Oh yeah, plus 1.
Which is B.
Oh yeah. Oh, just the number. That's all they're asking. Yeah.
Which one of these things tells you what N is, pretty much.
Gotcha. Which is number as well. 60 boxes. Estimation. Yay. 3,000. 60. 60 boxes. 60. So then.
It's not 150 fucking thousand.
Why not? I like pens. Why can't it be 100?
What integer limit did they hit to get 150,000 blocks and not?
Yeah, 2,000. It's 150,000.
They must have hit an integer limit, like, and looped back around to like the negatives.
Oh, okay. Overflow of pens, so you get more.
76, 62. Well, it's gonna be like
60. Wait, how do you do this? Is there a way to do this quickly in your head?
So
I mean, let's pretend there was no multiple choice. I'm just pretending.
So let's say 6,000 would be like 100, right? So like 60 times 100 would be 6,000.
Okay. September.
So
Yeah.
what I'm thinking here is that this is pretty close to half of that. I was thinking it's close to a third of that.
Oh, yeah.
It's actually close to half of that.
So just
So that'll
half
give you
it.
that'll give you 5. So half of 100 is 50.
50. That's I like that. That's cool. 6,000 and half it. Nice. 150,000.
Yeah, it's like also process of elimination is not
Heck yeah.
500 or 150,000.
Yeah, true. If you did that one too, but no, it's definitely 150,000. But they were wrong. They were wrong in that case. But it's okay to be wrong. Like you can just do 16 and count the zeros and 3 zeros. Cheating.
Yeah, this is just 16,000.
Yay. 70 times 5,000. So there is gonna be 35 and 1, 2, 3, 4. 30,000. Right.
That's not. No.
No? Wait,
No.
what did I do wrong? Wait.
350.
Oh. Oh yeah.
35. Well, I mean,
my bad.
68 times 1,000 is already greater than 35,000. So it's 350,000.
Yeah, I forgot I did. It was
You
35.
need an extra decimal. You just need an extra digit, extra decimal place.
Mhm.
You had the right thought. You just need an extra decimal.
Oh, thank you.
I just marked it wrong and said you needed to write down in the right tool the exact answer. As is specified in the fine print on the bottom right corner of the page that you needed to use and that you need to zoom in maximum to see.
Oh, I would hate. That's something that would show up. That's like a welcome to the game type of crap thing. That'd be horrible.
Yeah, not really. Well, not really.
Or they should add it. They should add that into like Welcome to the Game 3, where you have to like constantly zoom in.
In order to find this text, you need to use inspect element.
Mm-hmm.
I mean, the thing about the reason why, I mean, a good reason why that isn't a thing in Welcome to the Game is I'm pretty sure you literally can't zoom in Welcome to the Game.
Yeah. Well, then they'd have to add a new system into the game itself to do it.
For friends playing cards, the deck is 70 cards. You start the game, you pile 15 cards in center.
And she does the remaining
then
cards.
he deals the remaining cards one at a time to each player until all the cards are
70 minus 15, so 60, 55. She's gonna deal a stack of 55 cards, then one at a time to 4. So 55 divided by 4, and then just drop the remainder. Right, so that's. I'm doing it a long way because I. 1. So what's the over saying? 3,
well,
13 cards.
That sounds about right.
Yeah. I'm gonna double check just because I'm.
Yeah,
I mean, double check on a calculator. Yeah, you'd say so? Okay.
No, wait.
Wait,
no. 14.
Jesus. Oh no! 13. Oh, damn it. Okay.
Did you press check or something?
No, I didn't.
Okay.
I'm almost.
It'd be 14 because you have 13, and that gives you 252. But some people are gonna get an extra.
Wait a second. So, for
one person is gonna get 12. The other people are gonna get 13, which is basically bullshit.
Oh, greatest number of cards any player.
Yeah, no, I meant
not
13,
all 4. I thought it had to be equal for all 4.
Yeah, one person's gonna get 13. Sorry, I just got one person's gonna get 13. The other people are gonna get 14. So yeah, it's 14.
Yeah. Okay, because I just what it's asking.
14 gives you the 52. 13 times 4 is 52. Some people are gonna get 14.
Yeah, two players will get 14.
Nope.
Oh, that was close. Thank you. You caught that.
3 people will get 14.
3 will get 14? Because wait, what was it again? 13 times.
55.
Yeah, the 55.
Minus 52 is 3.
Oh. Oh, 52. Okay. Yeah, okay. Sydney, Australia, Northern California. Off by 1.
Yeah, you got an off by 1. Don't be off by 1.
Okay, I'll try my best not to go off by 1 ever again. 12,000 by airplane.
Don't be off by 1.
I won't. I'll try to do It's 24. It's just doubled. See, Australia. I wonder if this is true. Probably. It's probably real. Real distance. So you can find the mistake first. You're gonna do it first, though.
I got street delay. Hold on, look.
Oh, hell yeah. Hell yeah.
I made a mistake, which is below.
I was like, who can find their mistake first? Like, I'm racing you. Stupid. Step 1. Oh, no. Oh, frick. I messed up. Never mind. It's not step 1. Wait.
Well, I don't know what exactly is there. Do they? Okay, well.
Step 2. Wait, no. Wait.
Okay, so.
9, 30, 45, 46%, 40. 45, 46%, 48. 7. So then probably step 3.
Wait, where are these numbers coming from?
You don't know where they start coming from? This is
they're doing. Wait.
This is the standard algorithm. This is what this is called, the standard algorithm.
Oh. Wait. No, I forget the standard algorithm.
Lol. Because you don't need it. You just do it in your head because you're so smart.
I mean, more often with this thing, I just use a calculator.
16, 4, 5, 6. Oh, fair.
What's the standard algorithm?
What you're seeing here when you multiply like this and put the numbers on the top.
Well, what I'm seeing right here.
Wait, I didn't get anything.
Tell me what it is that they're doing. What are they multiplying? Where does this 2, 4, 7, 8 come from?
So 7 times 4 is 28. So you put a 2 here, 8 down here.
Oh, that's what they're. Oh,
yeah,
that's what they're doing.
the standard algorithm.
Okay, that makes sense.
35, 6, 37, 30.
Well, that will be that. Well, the first number is right.
That's what I thought. Yeah,
the second, step 2 is wrong.
Oh, I didn't catch it. Oh, you actually did get it faster though.
Yeah, because step 2 is supposed to be one decimal to the left.
Yes! Oh yeah, you're right. They didn't put the 0. That's it. Nice. But now you know what this thing's name is.
Yeah, well, once I remember what the standard algorithm was, because like it's not something I don't do, but it's just I forget what it was called.
Oh yeah. Well, when I was in school, they never taught me the name. They just said, "Here's how you multiply numbers." Like I only learned it's called the standard algorithm when I was doing Khan Academy, like literally 2 weeks ago, and they called it the standard.
Yeah,
algorithm.
and also I don't do it like that. I think what I'll do is if I'm doing like a big multiplication like that by hand, I'll take one of the numbers, I'll do what that thing is times all the numbers that I need, and then I'll just add them all together with the decimal place that I need them in.
That's smart.
That's what I used to do back in like 4th grade or something.
Oh hell yeah, that's what they're supposed to
teach now. 17-digit number times like a 3-digit number. That's what I did.
I think there's like a. Is there a bug on my leg?
There's a quick way to do this, I think.
Okay. Wait, before you tell me, I'm not even sure if I got the right number or not. I might not have, but I want to guess what you're gonna say. I'm gonna. Maybe you're gonna do. Are you gonna do 59 times 200?
No.
And then 59 times 30. Okay. And then 59 times. Wait, no, that doesn't seem efficient.
There's like a really efficient, pretty like
really
sort of efficient way to do this.
Huh. Was my answer right, by the way? Is it 15806? Or did I screw up the? Okay.
So 1,
6, 9,
7,
5, 6%.
1170 plus 224 is.
This should be an 8. I already messed up.
1170 plus 224. 170 plus 224 is. I'm doing this like mental math.
Yeah.
3, 1, 4, 1.
This is wrong, actually.
No, 1170 plus 224 is 14040. So 14040.
Okay.
Minus 14040 minus 234.
14986. Jesus God, my hand is so bad. Mine 8736. Shoot, this is 234. I thought it was 3. Okay, wait. No. Mine 18, 27, 28, 29, 30. Never mind, this is a 0. 18, 19, 20, 21.
13. Yeah, 13. Yeah, what I was
Two.
so. Yeah, what I was doing, I got
Yeah.
13806, and I just checked it with my calculator, and it's right.
Oh, I had a 5 there. Let's see. 20.
So what you have doesn't sound right. But the answer is 13806.
18.
Do you want to know how I got that?
I do. I really do.
So
6.
there's like 5 different tricks that I use.
Wow, damn.
First of which is I recognize that this thing is 59. So what I want to do is I want to figure out what it is if it's 60, and then just subtract the thing once from it. So like, what is 234 times 60?
Oh, I thought you might.
Minus 234, and that'll give you 234 times 59. But then how do we get it to 60? I could multiply it by 6, but what I did instead is I multiplied it by 5, and then by 10. So multiplying it by 5, you can do divide by 2 multiplied by 10. So 234 divided by 2 is
Okay,
117.
go back. Multiplying it by 5, you can do, what did you say?
Multiplying it by 5.
Oh, then you can multiply by 10 and then subtract like one of them?
Yeah, so and to
Oh
do
my
multiply
God.
by 5, to do multiply by 5 with quick mental math, divide by 2 multiply by 10. So 234 divided by 2 is 117.
Wait, you can
times
do that
10 is
to divide, to
170.
multiply by 5? You can always divide by...
Well, what's 1 divided
What'd
by
you say?
2 times 10? 1 divided by 2 is 0.5 times 10 is 5.
Wait, 1 divided by 2 is 0.5. Times
10 is
10.
5.
Oh, damn.
That's basically
Oh,
what it is. So 234 divided by 2 is 117 times 10 is 1170. And then I'm going to
I can't even divide this by 2 that fast in my head.
234 to that.
There's so many steps.
1170 plus 234 is 1404.
That's going to be multiplied by 10 again because that just gives you that would just give you 6, but I want 60. So multiply that by 10, 14040.
What? I don't have enough RAM to like, process all these different...
14040 minus 234 is 13806.
Oh.
So the 14040 was 234 times 60. And then I just subtracted 234 from that and I got the answer.
Oh. But then that's even more work. 'Cause, like, having to subtract this is like... would be like a pain. Too. It's like...
Subtraction's really easy to do.
I always like...
I mean, if
Forget
you're writing it
numbers.
all out like that, it might be harder to do depending on how you're thinking about it. But like 14040 minus 234, if I have both those numbers like there in front of me, I can do that with mental math pretty easily.
Without, you can do all of this without writing anything down?
If I have the numbers 14040 and 234 in front of me, I can subtract them with mental math.
Oh, those numbers. But if you just have...
If I have them in my head, then it might be a bit harder. Like 14040, that makes that 38, that makes that 1, that makes that 6, and that makes that a 0, so 13806, yeah.
Yeah. My issue was, like, I couldn't read my own handwriting because it was so bad. But, interesting. So, but if you had this number, would you have been able to do all those steps to get to the final result in your head, do you think? Or do you think you'd forget, like, where you were? Because I would forget where I was. Because it was
I got to the 14040
yeah.
with mental math, and then that minus 234, I used the calculator for that.
Oh, okay.
Right,
yeah.
But it's like that's the point at which I'll be like, let me write that down, just so that way I can make sure I'm not forgetting that.
Yeah, I see what you mean. That makes sense. If I had just written clear, then it'd be... That's it. Wait, I hope this ends up being the same thing that you said. 13806. But I like the steps you followed. It's cool. It makes sense.
Yeah, it's the sort of thing that would
A lot of
actually
steps.
that I could actually, if I really wanted to, I could do that multiplication in my head using those tricks because that's the sort of thing that like it probably wouldn't be faster for like a computer to do it that way, but for a human it's faster to do it that way through with it's or not really faster, but it's easier to do it that way with mental math because there are less complicated things to do and there's less that you need to remember. Like there's only like one or two numbers that you need to keep track of at any given time. And like
Yeah.
that one, the most that you need to keep track of is like 4-digit or 5-digit. And like with that problem, the numbers.
One of the issues is like honestly, if a number has like 3 or 4 digits, then I can only remember the one number. I can't remember 2 3-digit numbers. Sad face. Without getting confused, and I'm like, what was my number again?
Memorize 32 digits of pi.
No. The furthest I can go. What's the furthest you can go in pi?
What?
What's the furthest you can go in pi? Because the furthest I can go is 3.14159. That's about it.
3.141592653589793.
Holy hell!
832795028819769.
Wow, beautiful. You have more digits of pi memorized than anyone I've met personally.
Remember like a month ago or a couple weeks ago or something, there was like this whole new hype around the new formula for getting digits of pi.
Really?
And I'm looking at it and I'm
Yeah.
like, well, there's a couple of things that you need to consider about whether or not a formula is going to be better than what we already have for doing this thing. Because thing number one, we're trying to compute digits of pi. So, and that's going to be a really intensive thing to do. So whatever formula that you are using needs to be A. It needs to needs to have something specific. It's all about how many digits are computed on average for how much computation power is required. For let's say 1 unit of computation power, how many digits does that get you?
So how to make it so it's super efficient.
So from what I was able to gather, the new formula that they have found for getting digits of pi,
Oh my god.
maybe not approach pi faster than like the Chudnovsky algorithm, but the Chudnovsky algorithm had more efficiency, so it got more digits for some like amount of computation power or energy. It got more digits than the other algorithm.
Okay. So
the algorithm that we've been using is still better.
With the Chudnovsky.
Chudnovsky.
Yeah. That's cool. You know what? When I was watching a video, that reminds me. When I was watching a video where it was comparing the speed of Python versus like C and C++, that's what they were using to test for the test. They were using the algorithm to generate many digits of pi and then comparing the speed. I just remembered that. And then I did look at it, but I couldn't. I was like, wow, this is too hard. Oh my god. Hey, now we can look at assembly again. It's assembly time. And I was wrong. I actually have to go in like an hour from now. My bad. It's not 6, it's 7. Usually it's 6, but now it got moved to 7. So yeah. Yay. Okay. So I was looking at... So now I know they were like hiding things, but I kind of wonder if I move on to whatever the next thing is.
This is formula that I'm talking about.
Oh, is it the true? I'm not going to be able to understand that at all. Sniff. Chernosh. Okay.
I sent it in text chat.
Oh. Beautiful. Wow. I see many numbers.
What I think, just looking at this, my impression of this is they took some like regular formula for finding digits of pi and just made it
more efficient.
Pre-compute like the next like 10 terms per each term, and then simplify it as much as they could, so that way it had the least computation power needed in order to do this. That's the impression I get from this. It looks like a lot of pre-computation.
Mm. And didn't you have to do, like, for example, when you were doing the, hold on, let me think for a second, because I want to try to pronounce it right this time. Lang Tinzan. When you were doing that, you did pre-computation, didn't you, too?
Yeah, I did.
For
Well, I
the
did
computer.
pre-computation. It's not really the same as. I mean,
Oh,
this
this
one
is
is like
different.
taking like from k equals n to k equals n plus 10, all the terms in between there, putting them all into one single term, and then combining things and simplifying. That's the impression I get from this. That's what it looks like.
Oh,
Like it really looks like
holy
they're
hell.
taking some other formula, but just doing a bunch of multiple terms with that formula at once.
How many, like, for someone to come up with a formula like this and do this, like, type of pre-calculation, if that's what they did, then how long do you think it would take a mathematician to do this? Like, when they start on day 0 or day 1, like, how many days does this take someone to do? Like, over a year?
From the beginning of math to the creation of this formula.
From the beginning of when they started working on this, and they're like, you know what, I'm going to create a formula for this. And then they start working.
Very long. Well, this is a very long time.
Okay.
Like well, this is the sort of thing where people have been trying to find something that can efficiently compute digits of pi for a very long time.
Wow.
Like for for like many years.
Many years. Okay, that's cool.
Like the original way they computed pi was like as an approximation using a polygon, which was extremely inefficient. And you would have to spend a really long time to get like 10 digits of pi or something.
Really? Oh.
Like it was extremely inefficient. But technically it worked, but it was also really bad.
Yeah.
This one, I don't know how this is proven or how you get to this point, but I know that someone else smarter than me did that, or at least smarter than me in that field did that, and that's how we get like millions or billions or trillions of digits of pi. And of course, they aren't using floats or anything. Like, why would they use floats? They aren't using floats. They're using like arbitrary precision numbers, because you can't represent a billion-digit long number with a float.
Oh, okay. Crazy.
And this is an infinite series, so there are infinitely many terms in this formula. But from what I remember, I think someone did it by hand, is like when you do just the very first term of this, you get a lot of digits of pi just from the very first term. So like let's say if you set k to 0 here, it's already really close to pi.
Oh. So what's the smallest amount of digits of pi you can get from this formula?
What?
Oh, what's the smallest amount of digits that you could get from this?
Like the least accurate digits.
So all it does is like your accuracy goes up.
Basically that symbol there. You remember I told you that's basically a for loop.
That
you
do
this from
infinite.
K equals 0, K equals 1, K equals 2, and keep adding.
Oh.
And you do that to infinity.
Okay.
Yeah, you do that to infinity, and what ends up happening is, also I feel like
it approaches pi more accurately or something.
Yeah.
Oh,
yeah, and also I feel like wait. I feel like there is another optimization here. 640320 raised to 3k plus 3 over 2. If you pull out the divide by 640320 to the 1/2, which is square root of that thing, you can then you don't have to do that on each step. I don't know why they didn't do that. Why did they do that?
Oh.
I sure hope nobody's just keeping that in the thing. Or I mean, if you're gonna program this up, they'd definitely do some other optimizations like pre-computes and stuff.
Yeah,
Let me see if I can figure out.
I was gonna say, you think they would, someone else would have thought of that in that case. Maybe I'll show what we're talking about.
Let me see. Detail for this phone can be found there. Well, let me see.
Oh, nice.
Oh, let me just do this. If I just go in JavaScript and I do var k equals that's one. That's just one. So I can get rid of that. That's just one. So
Guess what? I actually don't have to go because the thing was canceled. I was like, look at my phone.
5, 4. Wait, you don't have to go at all.
I don't have to go at all. Yeah, because my thing was canceled. So hell yeah, I didn't want to anyway.
I wonder what it was.
It's work related.
5, 4, 5, 1, 4, 0, 1, 3, 4, plus 1, 3, 5, 9, 1, 4, 0, 9. Divided by, that's 1. That's 1. 6, 4, 0, 3, 2, 0 to the 3 over 2.
I heard numbers everywhere. Numbers.
Right. What can I do? 12 times that, and then 1 over that.
Where's my thing? Oh.
1 over that.
Let's see what's next.
Oh, I need. Oh, this is 3 plus that.
Oh.
Am I doing something wrong here? Why don't I just do this in like Desmos?
Desmos.
I can just type this thing like as is.
What were you using right now?
I was just doing it in JavaScript, and I feel like I'm typing something wrong. So.
Oh, okay. You should have been using JS truck. That's what you should have been using.
No, fuck
yes.
that. That'd take way too long.
To type it out.
That'd take way too long for me to do this
Okay. Excuses.
It's a pretty valid excuse, to be honest.
Kind of.
3K, toil.
Superbrain says, yo, what up?
What up, Superbrain?
3.
Sup? How are you doing? I wonder if in this entire assembly thing for
I haven't
exorcism.
even been paying attention to your assembly.
Oh no, that's okay. I wonder if there's skipping code in all of these. Like, I don't know. Maybe not.
I mean,
This one's...
So let me take a look at this. I'll tell
What
you
about
what's
this?
up there right now.
Yeah, does this one that I'm doing right now, this is called twofer. Does this look like they're skipping? Or that I can actually straight up write assembly?
There's no code here.
Oh good,
no
so I can just
code here.
write straight up write.
Yeah, so what does it want you to do?
It wants me to do something. So I'll start by doing that. And then I solved it. Semicolon.
Semicolon.
Okay, maybe not in assembly. I guess no semicolon, just new. Yeah. Okay, what they want is
There's no line terminators in assembly.
so just everything is on one line.
Well,
Oh wait,
no,
put
put everything on. No, the way you denote that it's the next line is by entering a new line.
Oh, okay, new line.
And semicolons are used for comments.
Oh, that's why you have this one here. Provide your implementation
And
here.
regular colons are used for labels.
labels. What are those?
Basically, it's like
Superbrain says they stole that from Python FRFR.
They still. Oh, it's just like the Python version of that. Then I know what it is.
It's basically something that you can use a go to on. You use the jump instruction on.
Oh, that's cool. To go back to the label or go to that wherever that label is. So it's just like naming a variable, kind of. Right. Hey, and hi, Superbrain. What's up?
I know why I got this wrong.
Why did you get it wrong?
6K.
He's in the middle of looking at this. Like I'm doing that over there, and then
Superbrain says the no line separator thing.
Oh, that's what you were talking about. Oh, sorry, I thought.
Well, I'm pretty sure assembly came way before Python, so.
For sure. Wait, this is the new. Oh wait.
Superbrain says the new Pi formula.
Oh, you know what, Superbrain? I thought, dude, Corrupt. I thought you were showing me the Charvinsky thing.
This isn't the new Pi formula.
Okay, this is the old one.
This is the one that they've been using to get like millions and billions of digits of pi. The new one, from what I hear, is less efficient than this one, because really what matters is whether it's actually really a breakthrough for computing digits of pi is how much computation power for how many digits of pi on average. It's like, let's say if you break it down to like let's say 1 unit of computation power, do you get more digits on average? Do you get more digits on average for this algorithm versus that
Superbrain says right.
And from what I gather, this one, the Chudnovsky algorithm, is more efficient in that regard. You get more digits per, like, let's say, unit of energy or computation energy and time than you do with the new algorithm.
And then he's been spending time trying to do something with the 3k plus 3/2.
Okay, so
simplify it
with the first term of this sequence, when you take the reciprocal of it to get pi, it gives you
Superbrain says I feel like I might have seen Matt.
I actually think so. Looking at this, it's giving me floating point 3.14159265359. I'm looking at that in decimals. Let me actually do this. K equals 0, and then I'm gonna do set K to this. Hello? Why can't I do that? I need to do, let's do N. Let's do like A equals 0, set to that. 3, 4, 5. Can I set this to 9? That does work. So 3, 4, 5.
And while you do that, I'm going to read my instructions. In some English accents, when you say 2 for quickly, it sounds like 2 for. 2 for 1 is a way of saying that if you buy 1, you also get 1 for free. So the phrase 2 for often implies a 2 for 1 offer. Okay. This is the assembly thing.
So,
Superbrain says
I'm looking at this. I'm looking at the output of this thing, and it's accurate. I'm looking at this, and the first term of this sequence is accurate down to, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 digits. So just doing k equals 0, like setting k to 0, and then doing that algorithm there, and then just ignoring all the other ones, you can get pi accurate down to 14 digits.
Oh wait, that's the lowest amount.
Yeah, wait, that's the just the first term of first term of the sequence gives you pi accurate to 14 digits.
So that's the pre-computation that they've done. 14 digits of pi, like each, or at least for the first one, it's like 14.
Well, whatever other formula they're using, there's that.
Oh, this is cool.
And the reason why this is especially fast is because like with that 640320, the most complicated thing here really is going to be the square root, because of that divide by 2 in the exponent. There's going to be a square root there, but that's literally a constant that you can pull out of the expression and only compute that once. So everything else is just multiplication, addition, and division.
Damn. Okay.
And some of it is also stuff that you can just reuse the values of the last term or the last iteration, and just use them for the next one.
Yeah, it's saving, so then you don't have to calculate that all over again. That's cool.
Mhm.
It's magical.
But like it's almost like accurate enough to just cover it completely to just cover it completely in floating point. Yeah, like if I take the next term, it's
Superbrain says I can't type
exactly
carrot carrot
the
carrot to
closest
concur with
pi that it
corrupt
can be in
anymore.
floating point.
Wait, what? Oh, is it because he's in VC with me, right?
What's going on?
Oh, Superbrain said that they can't type carrot 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 to concur with you anymore.
Oh.
Lol. But that's okay, because he can always just say carrot 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 whenever he wants. Test gets to determine what you will say as you give away the extra cookie. Wait, okay, I was like, where's the cookie? Imagine a bakery that has a holiday offer where you can buy 2 cookies for the price of 1. 1 for 2. 2 cookies for the price of 1. Oh, 2 for 1. Why did I read it 1 for 2? You take the offer and very generously decide to give the extra cookie
Superbrain
to someone
says
else
I
in
was
the
going
queue.
to agree with being able to take out that square root.
Very generously decide to give the extra cookie to someone else in the queue. Your task is to determine what you will say as you give away the extra cookie. If you know the person's name, e.g., if they're named Do Yun, then you will say, 1 for Do Yun, 1 for me. If you don't know the person's name, you will say you instead. 1 for you, 1 for me. Here are some examples. Yeah, one for you, 1 for me. Yeah, I do not know enough assembly to even begin to solve this.
Where's this instructions?
Oh, it's simple.
So, don't know the person's name. Okay, so well here's my question.
Yeah. Strings.
Where is this data?
Yes.
Like how do you access like it's saying yeah, can you scroll up?
Oh, do you want to see the test that it runs on your code?
Sure. Like I want to know like where's the data that they're looking for.
Oh, Unity. Okay, that's probably random. Name care buffer. Tell me if you want me to scroll up or down or whatever.
Well, give me a second. That's what I'm see.
Oh, okay.
Yeah, because the thing is, like, I'm looking at this and I'm not entirely sure where the data is coming in from.
Oh, so we can like interact with where they're with the data.
Superbrain says I feel like you need at least a 1 for an O, 1 for me. Somewhere. O and a U. Maybe as a DB? I don't know assembly.
So yeah, I feel like they might have. Like if this is supposed to teach you assembly, they might have skipped.
This isn't supposed to teach you. It says clearly there is no learning track. If you don't know assembly, you're gonna have to learn it. There's a warning when you start this track.
Oh.
Yeah, it's just a bunch of coding problems for assembly. That's it.
Okay, so what I'm guessing is going on here is you do need to learn assembly before you can do that. So
Yeah.
the problem. So what they're doing is they're making a call to that assembly code through C. So it's going to set up the values of those variables, or give you addresses to those strings in certain registers or somewhere in memory relative to the EBP or the RBP
Superbrain says only know
but
it from
you don't know how all that
and
works
most programs
yet
have
because
like this, you would
you
call
haven't
lots of
learned that
DB
yet.
entries.
Yeah, you're right. Okay, that's okay. So then I'll just maybe come back to this someday later.
Yeah, there are other tutorials
that are
like this
easier
one.
than
This one isn't. Yeah, there are other
difficult.
ones you should probably go to. Like the one I did was on tutorials point, I think.
Okay, maybe we'll try that one then. What about whatever this was? Did this look pretty decent to like read this? Just like go read through this.
Which one?
What I don't know. This one here. It's apparently like a little short thing.
let me see this. So scroll down. This is so this is Linux. That's Linux.
It
No.
is. Wait, just immediately no, just because it's Linux?
Superbrain says I
What?
feel like I'm
Oh.
It
interrupting
said it's from
Corrupt
Linux.
whenever I write
I'm trying to see.
LOL.
Do they have a Windows version?
No. But it would still be the same, like logic and stuff. Like, at least with, like, this, right? Like here?
Well, yeah, technically it'd be the same logic, but certain things like printing out to the console are gonna be different.
Oh, okay.
But I think the one from Linux might be the one they use on JDoodle. And so go on JDoodle,
And see what they use? Yeah.
and yeah, there's assembler NASM, I think, on JDoodle. So
So that's
with that one, Linux. Well, with Linux, you might need assembly to write your own drivers.
Superbrain says, well, with Linux you might need assembly to write your own drivers LUL.
Yeah, like kernel stuff and assembly. Yeah, that's usually where you do that.
Oh no, CAPTCHA. Motorcycle.
Which one's a motorcycle?
Motorcycle. This is a motorcycle. This is a motorcycle. 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 Motorcycle.
That seems wrong. A
That's
little bit.
what? This is a motorway. He's part of the.
Guess what? I have
This is part of the.
I have stream delay. I saw you clicking in the diagonal, and I was like, that seems wrong.
Oh yeah, the stream delay. Oh yeah, because you can hear me earlier on Discord. Yeah, I clicked on the diagonal. I was like, this is a motorcycle.
A motorcycle is the person in a motorcycle. Yeah.
Superbrain says is the shadow of
So
the
let me see.
motorcycle a
Okay,
motorcycle?
No.
Is the
Okay,
person
so
a
looking at this, I
motorcycle?
can tell you some things. If you
What?
if you set EAX to 4, EBX to 1. Actually, wait, let me see this. What is this doing here? 080 EAX. Okay, yeah. So if you set EAX to 4, EBX to 1, then ECX is the output, the memory address to where the output string is, and then EDX the length of the string. So if you want to print out, you have to set EAX to 4, EBX to 1. You have to do that by default. That's for print out. Then you have to set ECX to where the address of the string is, which there, if you look at the bottom there, they set that's like message and also sum.
Wait, but they never said set. Oh wait, they did. There's something like with 1 and 4 or something down here. Oh god.
Yeah.
Superbrain says, yeah, no, I don't know how to any of that either.
The section .data. And I could look at my own assembly code to tell you where the read in is. So if you scroll down, I think, all the way down, there should be a console somewhere maybe. Let me see on my end. Where is it?
I don't know why I can't scroll further down in this.
Can't scroll further down. Where's the console?
Oh, I have to say got it to the cookies.
No, where's the console? I'm looking at this. I don't know what the console is. Let me see. Maybe if I press this run button, there's a console.
Let's see what this tutorial says.
Okay, you have to press the run button in order for the console to show.
Okay. I don't know where that is.
What are you looking for?
Oh, I'm looking for the run button right now, but I was going
It's
back
top
to
right corner, the big orange button.
Orange.
Top right corner, yeah, there you go. There, see that button, yeah, that button.
Some of X and Y is 8. What did they add?
So,
X
if
is
you
5?
if you go down here,
Y is 3.
So what they did here is what they have here is they have 5 and 3 as characters. Oh, I gotta shut off my AC again. So I can explain this to you.
Superbrain says, oh, that is stupid.
Go ahead.
Stupid.
Oh, I don't know what is stupid either.
So what they have here, so if you look down at the bottom in the .data section, they have X, data byte, string 5. So what that does is it's gonna store the character 5 at X.
Superbrain says so.
Yes.
And so X is it's gonna have the character 5 stored somewhere, and they can't add you can't add 2-digit numbers with this, no. And if the output is 2-digit, it probably doesn't work either. But so what they have here is they have 5 and 3, and those are strings. So those are not strings, but they're like characters, and they're 1 byte
Superbrain
characters.
says, like I said.
Oh, 1 byte. So that's 8.
So
Yes.
yeah, so one of the things that's really important to know, if you look up the ASCII chart
ASCII chart?
and find out where the digits 0 through 9 are in there. So each of those all have an index. Like you see, like the decimal, hexadecimal, octal, whatever. They all have an index, and you see where the digits 0 through 9 are. They're on the second column.
Yeah. Wait, it's not here?
Second red text, second column.
Oh, this is decimal number for the character. Sorry, you're right.
Yeah, so you see where the digits 0 through 9 are, where the ASCII characters 0 through 9 are, right?
F
You
Yeah,
see how they're all
here.
you see how they're all one after the other, and they all have their decimal values or their actual ASCII codes, right?
Okay.
So
Yeah, for decimal 48,
so let's
49,
say
50.
let's say this. This is going to be pretty important for you to remember.
Yes.
Let's say I have the character 7, and I want, or let's say let's say I have a character 7, and that's going to correspond to the number 55. Like if you store that in a register, it's going to store the number 55 in the register.
Okay.
How do I turn that from the character 7 into the number 7? So it actually be the integer 7 instead of the character 7. This is actually something I think you can also do in C#.
The character 7. Oh, because it's an ASCII character into the number
Yeah.
7. I guess you need to like convert it to that, but
There's a really, really easy way to do this.
okay.
Subtract the character 0 from it. What's the code for character 0?
Okay.
48.
Yeah.
What's 55 minus 48?
48 is 15 minus 8. 7?
Yep.
Okay,
Okay, well now let's take the character 5. What's 53 minus 48 for the character 5?
Oh, this is black magic. Okay. I mean, it's probably gonna be. Oh, it's 5.
So
Wow.
that's that's gonna be really important. If you have a character as text from any numbers 0 through 9, and you subtract the character 0 from it, that'll turn it into the number 0 through 9.
Oh my god. Okay.
And you can I'm pretty sure you can do that in C# as well. I feel like I've tested that before and it worked. If you have a char and you set it to like character 9 or something.
Wait, so this
and
was
you
very
subtract
like where?
the char 0 from it, then you can get the number 9.
Is this just like a coincidence that this works?
No, I feel like that's
This
probably
is
designed
intentional.
specifically to do
Oh, for that. That's nice. That's a cool feature.
that. Like,
Wow.
there's another thing that is also probably not a coincidence. If you look at the alphabet letters,
Okay.
so let me look at this real quick.
Okay.
No, scroll up a little bit. Don't scroll down. Just show me the whole. I gotta see the whole table.
Oh, okay.
Okay, so 65, 97. Okay, so if you take any letter of the alphabet, like any capital letter of the alphabet, and you add 32 to it, you get the lowercase of that same letter. If you take any lowercase letter of the alphabet and you subtract 32 from it, you'll get the uppercase of that letter.
Wow. See.
And 32 is a special number because all you need to do in order to do that is do bitwise OR. You don't even have to add. You can just do bitwise OR or bitwise AND or bitwise XOR to swap between them.
Okay, you're gonna have to repeat the second part, but I see. So that was intentional. That's why they have all these like symbols in between the Z before you start again with the A, B, C, D lowercase, so that you can have that relationship. But whoa, mind blown.
So now if we go back to the assembly code.
Okay, where's that?
Actually, can you screen share on Discord so that way I can get this more in real time?
Oh, okay. I can. Yeah, I'll see. It'll probably lower quality, but.
Well,
yeah.
that's fine. Well,
Does
just set
it-
it to
you know
just
what,
set it to better text readability.
Okay, I'll do that. Because I'm streaming to send that. I'm streaming to 3 places actually. If I do that. Maybe there's not a delay on the YouTube one. I don't know.
5 plus 5. Do you mean the characters 5 plus 5? Let me take a look at this.
What?
I'm talking to the person in the chat.
Oh.
This tiny brainy chat. So, if you're talking about the characters 5, character 5 plus character 5 does not give you colon. If you're doing character 5 plus character 5, that's going to be 106, which is the letter F. So like this.
I didn't forget. Where's that? Did I close the? Where's? Oh, it's here.
Oh wait, no, actually, no, it's not F. Wait,
Corrupt
never mind, it's
converter
not F.
says
So
5 equals F.
Oh, it's not F. I miscounted. Actually, no, I was just looking at the wrong thing. So 106 is J.
Corrupt converter says 5 equals J.
But character 5 plus the number 5 will give you the colon. And so there's something for you that's going to be important to recognize when you're doing stuff in assembly is every single thing is a number. Everything is a number. And the only thing that makes it not a number is how you interpret the numbers.
Yeah, I figured.
So like the text, these ASCII codes, they are not letters, numbers, or symbols. They are literally just numbers, and you interpret them as letters, numbers, and symbols.
Yeah. And then the display will display them as.
And then what a string is just a sequence of these letters, numbers, and symbols all in a row.
Mhm. Makes sense.
And it's gonna be fun figuring out how to do memory in here. So.
Oh yeah, I'm actually most excited about working with memory.
Yet, by the way.
I know I haven't yet. Okay, well, Superbrain, you're around, so let me know if the stream quality gets really bad if I'm screen sharing on Discord. Just let me know if it changes, if it's like really bad or laggy or something. So I'll just stop screen sharing on Discord.
Just make sure to do better text readability.
Yeah. Okay, I haven't switched yet, but I'm just letting you know. I'm worried it's gonna reduce stream quality.
Superbrain says fine so far.
Okay, where do I set that setting? For text readability. Do I have to actually start the stream to do that setting?
So under when you click on the thing, there's a screen quality thing that says smoother video, or just set it to better text readability. Smoother video or custom set it to better text readability. There's a drop down.
Okay. Wait, I'm gonna try to find. Okay, there's a gear stream settings, stream quality.
No. Wait, gear stream settings? No. Wait, streaming on Discord. You press the. There shouldn't be a gear anywhere.
Oh, there's a gear.
There shouldn't be.
Okay.
Where's the gear? Where are you getting a gear?
You hover your mouse over where you're streaming, and then there's a gear icon. It says stream settings, but then you only have a stream quality.
Are you already streaming? Okay.
Oh, I guess I don't have that. I'm gonna go 15 frames per second. I'm manually gonna do this.
No, just do better text readability. That's 5 frames per second.
That's even better, but I don't have that option.
What do you? Okay, no. So when you click on the window, okay, stop the screen share and then go back to the share your screen button.
Okay.
Yeah, you stop the screen share and then click on the button. Click on the window you want to share.
Okay, I'll try that. Screen share.
And then there should be a thing that says stream quality. We see it says resolution, frame rate, and all that stuff. This thing says stream quality, smoother video, click better text readability. Or it might say custom, click better text readability.
Okay.
Did you do it?
Yeah, I did it.
Okay, good.
Yeah.
So it should be yeah. This looks good.
Okay. Something about homomorphisms between the ints and the characters here. Oh, especially with the way you are subtracting and adding zero.
Well, the thing is, Superbrain, nothing is there are no letters, there are no numbers, there are numbers. There are no symbols really. There are no there are no images. There's every single thing on this level is basically just a number. It's all numbers. You're working with numbers, and everything that you do is just operating on numbers.
Everything is just numbers.
The only thing that makes these letters is that we've decided that these numbers are these letters, or these numbers are these symbols. But to the computer, it's all just numbers.
If everything is just, you said everything is just numbers, so AKA hell.
I just fell backwards. Almost just fell backwards in my chair.
Superbrain says yeah, it just feels a bit like switching between adding and multiplying with log and exp.
Oh Lord.
I guess.
I hate logs. I hate logs. Ugh.
Logs and explodes do kind of make things a little bit inconvenient, but they're not too bad.
Okay, I have to get more used to those.
Sometimes.
At least you're being honest.
I mean,
I appreciate
when
it.
when you're doing algebra, really, you don't. For the most part, you just need to memorize the rules, but you don't really care what it evaluates to because it's all letters, and you don't care you don't care about what's log base 2 of 5. Who cares? You just write log base 2 of 5. So, looking at this assembly.
Yes.
Move or mov EAX, and then in square brackets X. So what those square brackets means is interpret X as a memory address and read from that memory address.
So we're naming EAX X, like we're giving it the memory address.
So if you look at down at dot data, and we see what X is, we see X is going to be the value X is going to be some memory address.
Oh,
and at that memory address, it's going to the string 5, the
will
character
be put
5
in EAX. Oh damn. Okay. Cool.
So that's important. X is not a variable. X is a constant here, and it's not the character 5. It's a memory address to the constant 5.
Okay. Wait.
Basically, it's like a reference, pretty much. It's like a reference.
Reference. Okay.
This first line is reading at that memory address, so it's going to read the character 5, and it's going to store it in EAX. Now, one thing I'm a little suspicious about looking at this is that EAX is a 4-byte register, and this is 1 byte that you're reading from.
Oh yeah, I have the same question as Superbrain.
Yeah,
Superbrain's
it's a pointer. Do you know what you might not know what a pointer is.
Well, now you're gonna teach me, I guess. So which is the pointer? It's this X is the pointer.
So X is a pointer. Yeah,
oh, wow.
X is a pointer. And a pointer is again, it's
points
just
to
a
memory location.
It points to a memory location. You can use a pointer to read at that memory location or near that memory location.
Okay, cool. Hey, I finally learned what a pointer was. Yay! Wait, guys, do you guys know?
And then you can see in here, literally exactly what I said. We're moving we're moving the value of that character 5 to EAX. And then we're subtracting the character 0. There is one thing here that I'm very suspicious about, which is that they're storing a single byte to a 4-byte register.
Joe.
Their second thing's a pointer. Well, yeah, that's what you get when you're doing. That probably comes from like C++ code or something. That's the sort of thing that you get when you have to go through different multiple layers of pointers to get to a value.
Oh, lol. Oh, so I guess pointer points to a pointer.
Pointer is a pointer to a memory address.
Amazing. Which
is something that kind of does exist. It technically does also completely exist in C#, but like if you pass something by reference instead of by value, like in C#, if you pass in a parameter to a function using the ref keyword, when they edit that value, when they edit that variable inside of their function, it'll edit that variable outside of the function. Like to the person calling it, their variable will be edited too.
Oh, to other, so it'll affect other functions.
Yeah, if you pass in an int by reference, when they edit that into like say 5, and they set it equal to 5 inside the function, it'll set it equal to 5 in the variable that you passed in. That is a pointer. So like the variable is a pointer to a memory address that stores the number 5. And then the pointer is the pointer to that memory address stores number 5, and that's pretty much what's going on there.
I understood the pointer to the memory address, but where's the?
Yeah, you can pass by ref and do that.
Oh.
It's a whole thing.
Pointer to the pointer is where things got tricky.
Mm-hmm.
Pointer.
So. Okay. So anyway. So looking at this, I'm gonna ignore the fact that they fucked up this code. That they made a little bit of an oopsie by storing by storing a single byte into a 4-byte register, and as such, they can have undefined behavior. I'm just gonna ignore that.
Oh.
I'm gonna pretend it doesn't exist.
Okay, it didn't exist.
So
let's
the
fix
first
it
line
together
is,
then, because we're here. Or is it too hard to fix it? Can you just like change one line?
I could.
Oh.
So let me think about this.
Oh, okay.
Where's sum? Oh, sum is 1 byte allocated.
Superbrain says this might not help, but is EX now a single char, or is it a null terminated string or a length prefix string?
EX is a 4-byte integer. EAX. So the thing is, this is nothing here is like there aren't strings. There aren't strings. It's all like all these registers, everything here. It's all just going to be memory addresses and integers, and memory addresses are integers. So okay, let me get back to this. So if you set I gotta remind myself. How are these things laid out in memory? Registers. How are these laid out?
Well, maybe that.
Okay, I'll edit. I could make changes to this, but so if we look at that thing.
Superbrain says yes, sure, but a 3-char string fits into 4 bytes of string.
Yeah. But the problem is, because we're reading a 4-byte value from memory. The reason why I don't like the way they've written this is that it's not reading a 1-byte value from memory and storing it in a 4-byte value. It's reading a 4-byte value from memory and storing it in a 4-byte value. So, like, you get that character 5 as the first byte, and that's fine. But what are the other 3 bytes that it's loading into that register? And those other 3 bytes are perfect room for undefined behavior. That's why I don't like it.
So what goes in there? Like just zeros or something?
No, it could be any literally any random numbers, because that's what we call undefined behavior.
Oh, because undefined.
If you just read from a random memory address, you don't know what's in that memory address. So whatever's in that memory address is loaded into.
Oh, it's like there's something that could have been in there.
Anything
before.
Weird whatever is in it before.
Yeah, it could change.
So that's why I don't like the way they did it, because it opens it up to undefined behavior.
Okay, well that's
so the way there are registers that are 1 byte long. So the way I would have done this is I would have instead of using EAX, I probably would have used the AL register. You don't need to change this, but before we do that, I'm just gonna explain what all this means, and then maybe I'll write down what the more proper version without the I forget what it was called. What I literally just called it, undefined behavior. What the potential undefined behavior was. I mean, this program probably doesn't do that, because it's simple enough that it won't have that problem. And it's designed in a way that it won't have that problem. But
but if it was a real application, you could have this problem.
No, it could still have that problem, because you have 1 byte allocated for the memory address as sum, but you're storing 3 additional bytes to that. So this code there's problems with this code.
Okay, let's send an angry email to JDoodle support. Like, your code sucks.
Okay, so
you don't know anything.
Yeah, your code opens up to undefined behavior.
Yeah.
It's probably fine. It probably works every single time, but just saying. So
that's fine.
So move EAX. So the way this works is the thing on the left, and you have the thing on the left and the thing on the right. Whatever the value is on the right that value is being copied and stored in the thing on the left.
Wait,
Superbrain says, so does X know it is just 1 byte long? Or would
nothing knows how big any. No, it doesn't know. It does not know. The way you indicate that something is a specific size is by using like the byte keyword or the using the byte keyword or the word keyword or D word keyword. So byte is 1 byte, word is 2 bytes, and D word is 4 bytes. There are no 3-byte numbers, by the way. It's 1, 2, 4, or 8. And there's also 16, 32, and 64, but we won't do that.
Oh, because everything's a power of 2.
Yeah, everything's a power 2.
And yeah, it makes sense. 'Cause binary.
So I point that out because it's reading 4 bytes from the memory address X, because X doesn't tell it that should only read 1 byte. Nothing tells it that it should only read 1 byte at this point in the code.
It reads everything.
The way it interprets this is X is a number, and read 4 bytes from that to store it into a 4-byte register. So I wonder if it would cause problems. I remember this. So this is storing. It's basically storing. So I'm just going to read this. Basically, what it does, ignoring the problems. This is storing the character 5 at EAX.
Okay. Storing the character 5 at EAX for move.
It might. Superbrain. It might be storing. It might be storing this string here. Depending on how that stuff is laid out, it might be storing like this. How is that? It might. Well, actually, Depending on the layout of this thing. It might be storing something like this inside of the EAX register. I don't really know because I don't know exactly how that lays out, how that gets laid out, but it might be storing something like that. So, this is storing the, what the hell? This is storing the character 5 inside of the EAX register. That's what we're going to focus on. And then the next instruction is literally what I told you to do before. Subtract the character 0 from it, and that gives us the number 5 stored in EAX.
Okay.
So now EAX is equal to 5. Not character 5, but number 5. And then EBX, we're doing the same thing, but with the string, with the character 3.
Superbrain says NDNS.
Reading from the address of Y.
Subtracting 0, turn it into an integer.
Mm-hmm.
Okay. Oh, and then you can just add them? Or maybe not. I don't know.
And then once now you have EAX is equal to 5, EBX is equal to 3. Those are the numbers. You add them together, and you're gonna get 8. So now what we're doing is we're adding the character 0 to it to undo the thing we did before. So now when you take the number 8 and add the character 0 to it, you'll get the character 8.
Oh, we want to return that.
Yeah.
Oh, yeah.
And then what we're doing is and then this next line is some is going to be some memory address and we have 1 byte allocated there to store a number. We are storing the value in EAX there, so that's going to store our new character 8 inside of that memory address.
So it's just you have all these other ones like EAX as like, oh wait, these are registers, you said.
Yeah.
And then this one isn't a register?
That's a memory address.
It's a memory address. Oh, this is long term. Yeah, these ones are short term. Short term.
Yeah.
Put it in.
Yeah, memory address is long term, registers are short term. So that's going to store the character 8 there. Now on this next line is setting up for a print.
Can you have an infinite amount?
I don't like the order they did. So you can have
addresses?
Well, you can't have an infinite.
Oh, it'll slow down eventually.
You're gonna. Well, no. Well, the problem with having an infinite amount is your computer doesn't have infinite RAM.
Yeah.
So this next line, we're gonna focus on 2 things first. EAX is set to 4. EBX is set to 1. So if I remember correctly, EAX4 is what you do in order to have it. What you do in order to set it to print out. And then EBX1 is where you want to print out to, and that's setting it up to print out to the output. So those things are preparing to print out to output.
What the?
There's documentation on that somewhere, but I forget where the hell that is. Okay. And it's not on Felix Flautier, unfortunately.
I see. And wait, if this is for memory like RAM, then what is there? Oh, is the register actually on the actual CPU?
Yeah, the registers are on the CPU.
The real okay, I see now. That's why there's so little of them, and then this one, the base one. Okay.
So now, so the EAX and EBX are setting up to print out. ECX and EDX are like the parameters. So ECX is the memory address of the string that you want to print out, and EDX, or the I'm gonna call these A, B, C, and D, just because I don't want to say E.
Yeah, that's fine, because EX is repeated.
So C is set to the memory address of the string that you want to print out. D is set to the length of the string that you want to print out, and that's important because it doesn't know how long your string is. It doesn't just automatically know that. You have to tell it how long your string is, otherwise it'll just print. Otherwise it'll just keep printing. And well, technically it'll print until however big you have EDX set to. If you set EDX to like 500,000, it'll print 500,000 characters.
Okay.
Message. If you look down in section.data, we have message defined as that thing. So message is a memory address. It's going to be a memory address, and at that is this value. Sum of x and y is that string is stored there.
So this is like. Wait,
So that's going to point to the left of that string.
Where are we? What are we talking about? Now?
So message. You see where message is? Message db sum of x and y is. So that's where message is defined. So message is a memory address pointing to the left of this string. So right to the left of s. That's where that is pointing to.
Wait,
that's what
memory
this is defining
to the left of the string. Wait, why is it to the left?
Sum of x and y is. You see where that is? It's because of the way things are ordered, and also.
You mean like these things are actually like sitting right next to each other? Like they're like if there was a picture,
look. I'm just talking about section.data. I'm not talking about the assembly code right now. I'm talking about section.data.
Okay.
Message db, where the value message is the memory address at the left of that letter s, in that string. So the first s. So.
Which s?
I wish I could click here. So like the very beginning of that string, that's where message is pointing to. It's a memory address pointing to the very beginning of that string.
Oh, it's pointing to the s of sum.
Yeah. So if you read the first character at that memory address, the first byte, it'll give you the letter s. The second, it'll give you the letter u. The third, it'll give you the letter m, and so on.
Mm-hmm.
And if you read it as a D word, as a 4-byte, you would get SUM space. And that'll give you those things. So what this is doing here, if we go back to the assembly where we were, is it's storing that memory address in ECX. Basically saying read from this memory address. It's storing it at the C register. Basically saying read from this memory address. That's where our string is. That's the thing we want to print out. And then in the D register, it's saying print out this many characters.
Okay. How can
so length is going to be the length of that string.
Mm-hmm.
It's defined in a really weird way, but
how can the whole entire string be stored in just ECX, just one of these?
It's not.
Oh, just the first character.
Just the no, not the first character. The address of that string, the location of that string is being stored.
Oh, the location.
It's not storing the entire string. It's storing the location of that string.
Location. Okay.
So, like, if you put message in square brackets, then it would store the first 4 characters of that string in ECX.
Oh, damn.
But because message is a memory address. And then in the D register, it's the length. Now, length is defined weirdly in the way they did it here, but pretty much what this means is just the length of the string. So that would be...
Where are we looking now?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12,
Wait, we're still
13,
looking
14,
section.data?
17, 18.
We're going to the next thing?
So len is 18. It's equal to 18.
Okay, because the amount of characters in the string.
Yeah, so the way, I'll probably explain you specifically what this is doing at some point, but I can't be bothered right now. But pretty much it's finding the length of the string. It's basically the thing we did before where they had problems with doing right index minus.
It's doing it for us. Like it's doing.
Yeah, that's what the dollar sign is basically the right index right now, and the message is the left index.
Okay.
How are they different?
So dB is data bytes. So that's saying we're storing bytes at this in this data. This data is bytes. And EQU, I'm guessing is saying is saying compute this and set this to that value. So that's like equate this to or something. I don't know what specifically I'm supposed to call it, but it's setting that to a number, pretty much.
You said dollar sign is the left left part, and then did you say this dash thing is like the
Dollar
right
sign is
part?
the right. Dollar sign is like the current position in the data, and then I'm guessing that's just a constant, by the way.
Dollar sign?
You're learning without putting in the
Superbrain
work to learn.
says
Yeah.
sorry for asking so many questions, but I
No,
feel
no,
like
you
I'm
just
learning
keep
without
asking
putting in
questions
the work
because
to learn.
this person next to me isn't asking enough questions.
Who,
So
me?
the dollar sign is the current location in the data. I'm guessing, and message is the location of message. So pretty much what this is doing is saying here minus minus
Superbrain
the
says
start of the
I
string.
see.
So the current position would be the end of that string, and then message would be the right left of the string. So that's right minus left to get the length of the string. That's what that's doing there.
Okay.
So you can imagine dollar sign is the very rightmost of that string, and then message is the very leftmost of that string.
Oh, message is the very leftmost. Okay. Sure.
So that's what that's doing. And then so that'll be, I think I said that was 18. So if you went to where it says len in the assembly and just replace that with 18, this should just work. This should still work exactly the same.
Say it again if you do.
Not there.
Oh, I'm not doing anything.
In
I'm
the
just.
assembly. In the
I'm not gonna
assembly.
do
Like
anything.
up the top.
Yeah, if
where
you
it
said
says len,
18,
replace that with
like
18
literally
and see
this.
if it works. Yeah.
Okay. Don't. I wasn't gonna actually type anything. I'm just asking
now
like
run it,
here
run it.
and here.
Run it.
Run. It.
Yeah. Now set it to something like 12.
Okay. So less characters that will show up. It'll cut off some.
Mhm.
Oh damn! Sum of x and.
Superbrain says clap.
Wow.
Yeah, if you set it to 11, then it would be sum of x, a, n, 8.
X A N 8. Yeah.
So that's, so
Let's put
that
it-
gives you an idea of what
One.
it's doing. State.
See. 10, and then added add a 10 at the end. Like.
Mhm.
Yes. Sorry.
Yeah, let's try 20. Let's see what happens if you do 20.
20,000.
Nah, it probably won't let you print
Superbrain
that out if
says
you do
so. What if you
20,000.
index
Okay,
I don't think the
200.
website will let you 200.
Aha. 8.
I like how it did actually print out the 8 because the 8 was stored right after, I think.
Why are there 2 8s? What the?
Because because of the way this is laid out in memory, 8 is stored right after 8 is stored right after that string because of that sum res
Superbrain
res
says
b
I
thing down there.
no.
Somewhere.
The allocation for our variable 8 there is right after where we've allocated that first string. The sum of x and y is we've allocated the memory for 8 right after. So when we print it, and this is the thing, like we printed right after it. Oh, and guess what? Guess what's up with those characters there?
What? They're.
That's a result of our of them using EAX or them using the 4-byte registers for 1-byte values.
Oh. That's the unintended behavior.
That's the
What is
undefined
this?
behavior. Yeah. So if you use I predict that if you use 1-byte registers for those things instead of 4-byte, you wouldn't get that.
But you would
But I
get
don't
this
know.
like weird 8 at the very
But
end.
yeah,
because of that.
you would still get that,
Okay. Why was?
and that makes sense. That actually makes sense thinking about it.
Oh, why wasn't there another 8 when we did 18? Oh, because you have to keep going
Because-
for.
Well, do 19.
Okay. Oh, whoa. I see.
So if you go down, so from line
Yeah.
32 to line 36, like comment it out, use semicolons to comment.
32.
Like comment out each of those lines with semicolons. 32, 33, 34, and 35, and 36.
36. And
Yeah.
then run.
And then run it. Now
Oh,
set
that's
the thing up above to 18. You might have
I just made that go away. Exit out.
be careful because I'm guessing you're on a laptop right now.
I am.
Like sliding to the side is like very very close to closing the whole page.
Oh. This? X? Okay.
You know what? I think I know where to avoid that issue. I think.
Should I just make this go away? What will this do? Want me to
Yeah,
improve
just
your
get rid
performance?
of it. Yeah, just
Okay.
get rid of it. We don't need it.
We don't like you.
So now what that is printing is it's just printing the sum of x and y is, and there's a space there, but you can't see it because it's invisible. I mean, if you select it, you'll see it.
Oh yeah,
You
8's
see if there's an
gone.
extra space there.
Who knows?
But if you do 19, because 8 is stored right after all that, because our computed sum or whatever that we stored is stored right after, you'll get the 8 there if you set this to 19. That's where the extra 8 comes from. So the extra 8 isn't the 8 at the end, it's the 8 in the middle. That's the extra one that came from setting it to 200.
Wow. Does this will always happen? Like it always stores the result as like an extra thing at the end of everything?
Only because of the way that the memory is laid out.
Okay.
So that's not like how it always does it, but that's how it does it because that's the way we've told it to do it.
Wow.
That's the way the program is written. So.
Ooh, okay.
So what do you think so far?
I think, something's interesting. Why?
Superbrain says what happens if lines 43 and 44 are swapped?
What happens if lines 43 and 44 are swapped? Yeah, so if you swap 43 and 44, yeah, do that.
Okay.
So if you swap 43 and 44, I predict that you will get a 3 there instead of an 8.
What the hell? Okay. 43.
Also put the yeah. No, don't worry about the thing that I was about to say. Don't worry about it.
There. Oh
Yep.
damn!
I knew it.
Superbrain says sounds
Now
reasonable,
undo that.
but still weird.
Weird, yeah.
So now after that, do like Z, DB, and then like literally anything.
Wait, what? What am I supposed to do?
Yeah. After that, after the message line, after 44, make a new line, and just like do like Z. Doesn't matter what you call it, but let's say Z and DB. The space. Z space DB space, and then just do double quotes and just type anything.
Anything.
Now, up in the in line 27, set that to like 24.
Okay.
And this is where memory leaks come from.
Ayoweza says why are you learning assembly LUL?
You literally freaking told me to learn assembly. You have no right to ask me why am I doing it. You literally like, learn assembly. And I'm learning assembly, okay? People leave me alone. He used to tell me to learn assembly.
So you notice this?
Huh? What? Oh, this. Sum of x and y is anything.
And if you set it to 26,
Oh, it
Ayoweza
comes.
says but not like right away.
because it comes right after.
Yeah.
Well,
That's cool.
Okay,
Wait,
so,
I wanna-
so how long have you been programming for?
I want to say I
Superbrain
just
says,
started
I remember
today.
I learned about memory.
Oh, you
leaks
mean
from
Aya?
Hartley
You're asking
back in the
Aya?
day.
You're not asking me, right?
I'm asking you. How long have you been doing any programming for?
It shouldn't. That's like asking someone how long they've learned Japanese for when you haven't studied in like 2 years. It's not fair. Question.
Well, how much time do you spend?
Good. That's fair. Fair question. I spent before I met you.
Ayoweza says
Honestly,
like weeks LUL.
I probably spent like 20 hours. That's how bad.
No, well, okay. So I mean, I don't really mean. So, okay. How many days? Like
I took CS
so,
101
if you take
in
breaks,
college.
whatever. I mean,
Yeah.
like, so how much time? Like, let's say this. Add together all the days that you have worked on learning coding. How many days? Is that?
Even a little.
Yeah.
Okay. Then.
Like how many months or years or whatever do you think?
So even if I did like 1 minute of coding or trying to think about.
Well, maybe a bit more than 1 minute.
Okay, give a time so I can. How much?
Let's say like at least an hour.
At least an hour. Okay, fair. Then I say, let's see, how. How many days? You're...
Superbrain says
Guys,
that's like asking
hey.
how much bread have you eaten in your life.
No, I feel like I'm gonna ask how much bread I eat, but I'm gonna try to calculate, give a general estimate. Great, this is not a helpful answer.
Okay, well, how long would that course be, I guess?
I don't even remember
Like
how the credits
how many
were.
months? Like you can give it to me like in days, months,
I don't
years,
remember.
however.
I genuinely don't remember.
Okay.
Okay, so 15 to 17 is a good estimate. I'll go 16 in the middle. Well, this is a semester. A semester's half a year. Does a class last half a year? I think, or a quarter. I think half.
Ayowaza says a semester.
It's like one class, right? If you take a class in college, it's lasts usually one semester.
Okay.
A semester's not 2 years.
So for a while, especially I'd say for a while, compared to how long I had spent coding when I started assembly.
Ayowaza
I
says
did not.
yes.
I probably didn't spend nearly as much time as you. To be honest, but you do learn things a lot faster.
I started assembly about maybe like a month or two after I started coding in C#. Like after I did my first ever coding.
Okay.
After I did like my first ever coding, I did assembly because the problem that I encountered required that I needed to learn assembly to solve it.
Okay, so you went wherever you need to go to solve what you needed to get done.
Yeah. But then after I did assembly, after I spent like a month or so on assembly, I noticed that like when I went back to high level languages like C#, I noticed that everything that was like hard before now just felt really easy to do. Like I didn't have any problems coding anything unless unless it was just something that was really hard to do. Like whereas before I was struggling just to code like in general, but after I did assembly, it was really easy to code in general and to solve most problems.
Didn't you say something like that also, Aya?
I think like after I did assembly, just like right after that, maybe for a bit of like getting myself back into the groove with high level languages, I was better at that time, probably in like sophomore year maybe, than the entirety of my programming class in senior year at the end of senior year.
That doesn't surprise me.
And that was not too long after I started coding.
Superbrain says it's like putting weights on your legs.
The thing is, it's like coding and assembly is difficult.
Feels way easier.
Coding and assembly is difficult. Like doing basic things is honestly pretty tiring to do in assembly because it's like you have to do all the time. You have to break it down into really tiny little things. Like even multiplication is pretty inconvenient in a lot of places. But after you do assembly for a while and then you go back to languages like C#, it's just gonna feel like damn, this is many times easier than doing the exact same thing in assembly. And that's why I think this is an idea. Why I want to test this, because I feel like if you do a language like assembly, if you learn assembly and then you go and do like lower level like higher level languages like C# and stuff, it's downhill battle. Instead of it being an uphill battle by learning harder and harder languages, it's a downhill battle.
Yeah, someone else said that earlier. In any case, I mean, I'm down for the challenge. He literally, Corrupt said experiment, so we don't really know the results.
I am not saying that she shall tea, but maybe latter.
But, you know, like, I'm having fun, so I'm learning things.
I would say that they are more experienced in coding right now than I was before I started assembly. So.
Wow.
So like,
it's hard to even imagine. You're so smart, Corrupt. You're so smart, though. You're so smart.
Yeah, no, I used to be. Yeah, well, of course. Yeah, well, of course. The thing is, I used to be bad. So I used to not know how to code at all. That's crazy. Imagine that.
There was a point where we all didn't know how to code at all. Everyone, you know, there was a point we couldn't even like use the toilet by ourselves. So help us.
Yeah, back when the tower fell, I didn't know how to code.
Did you know how to speak?
No.
Oh. Aww. See?
I didn't know how to breathe either. In fact, I didn't know anything.
Okay. Damn.
And in fact, I wasn't even anything.
Oh, non-existent. Okay.
So what we have here should give you an idea of kind of what's going on, how these things are like laid out right next to each other in the data. because it's printing out like what comes immediately after that string when you print beyond the length of that string.
Yeah, yeah. It's strictly in order. It's like this thing's
Yeah, that's gonna be a common theme. There are no borders. So one of the things here is that there are absolutely no borders. The only way that you have like I mean there are probably things that you can do with special instructions, but for the purposes of this, what we'll do here, the only way that you stop yourself from reading outside of the allocated space for an array is by making sure that your code is coded right. Because
wow. So you can
because there's really nothing
Stopping you
stopping
from
you
doing it.
from reading
Added
outside the
from
length of
3
the string
here.
to memory that you shouldn't have that you haven't really allocated or
Well,
done
and
it,
that's
or
that's what
things
happened
like
when we raised it to 200, and then it gave the random
Yeah.
like 8 is like
Yeah,
it's
like
going
what
outside the memory of what
this thing is
said.
doing is it just has some. I'm assuming the dude just has like space allocated where it's just all zeros there.
Oh, okay.
5 must be padded from 3 here. It'll print out. Okay, it'll print out if you print it out X just like exactly there. I think it would
Oh,
be
you're reading his message.
it'd be this 5 3 SU. Like if you print it out straight from X, you could actually if you set 226 to from message to X.
Superbrain says
Instead of
else it would
message.
read 53 soon.
Yeah, it should read 53 soon.
Ooh, you're
So
getting a
I-
super brain. You're so smart.
Yeah,
That's
so
what I mean.
set
Yeah.
so set 26 to instead of message, set it to X.
And then run.
And then print. Yeah.
So it's 53 still.
53 sum. Yeah.
Oh.
Superbrain says, but how does MOVEXX know to only read 1 byte?
It doesn't.
Oh, he just do every.
It just doesn't. Yeah. It reads 4 bytes, and so what it's doing there. So what it's doing there is it's basically this.
Uh-huh.
It's not reading from EAX. That's what's going on.
It depends on the register
So
size.
Superbrain, look at what it prints after 8. So if you know that 8 and those 3 characters after, that's 4 bytes. Those 3 characters, if we weren't using the 4-byte registers, those would all be dots because those represent 0. But because we're using 4-byte register, we set EAX to that. Move EAX.
Ayaweza says since EX
5-3
is 4
soon.
bytes long, it reads 4 bytes into the register.
They
at
aren't null.
once.
Yeah, the reason why those aren't dots is because they're not null, and the reason they're not null is because we're reading 4-byte values into EAX and EBX, and we're using the wrong
Superbrain
size.
says
That's why those look like that.
Oh.
Corrupt Converter says MOVEX 53 soon.
So it's too big to be null. This base allocated to it or something.
Yeah, well, the third one is
says
3
MOVX,
minus
sum.
S. The second unknown
Ayaweza
is
says you could use AL for the byte long
is
rigs in here.
S is S minus it's not 3 S it's plus, my bad. 3 plus S.
Superbrain says
That's
plus
3
surely.
plus S. The next one is S plus U. And the fourth one is M plus 0. The fourth one
What?
Corrupt Converter says SU.
it's M. It's U plus M. So that's what those would be. Whatever those ASCII codes are, I can't be bothered to figure them out. But that's what those 3
Corrupt
characters
Converter
are, and
says
those
UM.
are not very printable characters, by my guess.
Oh yeah, or just yeah. Not printable.
So like we can dissect this, but the thing is, like that's the reason why I said I don't like their code here, because that's not what you want to see.
Superbrain says, but of course there would be carries, right?
It would loop back around to
If
0.
UM is more than 255.
Yeah, it loops, well, okay, actually, yeah, it carries over to the next one. Yeah, you're right. It would carry over, well, Actually, I think none of those carry over. Because I think all of those are less than 128. I could be wrong, but I think all of those are less
Superbrain
than
says
128.
crazy unintended behavior.
Z lowercase z is less than 128.
Superbrain says well, but if they would carry over.
If they would carry over, then yes. Iwasa, however pronounce that. We are using. What we're looking at right now isn't code that we have coded. It's code it's example code provided by the website. And what I was doing is I was explaining to them what it was doing.
It's default. No, wait. Don't lie. I wrote this for myself, and you're just explaining the code I wrote.
Yeah,
to me.
definitely, yeah, for sure.
Yeah, but I wrote this, but then I had amnesia and I forgot what my code
Now
does.
I need to look at.
No, thanks, super brain.
I need to look at something.
Okay.
Something in my code, and you figure out how to do something.
Oh, I don't think you ever talked about what this int 0 times 80 thing is.
0x80. So that's 80 in hexadecimal. That's basically 128. That's the number 128. That's a hex. 0x. Whenever a number is prefixed by 0x, that means hexadecimal.
Oh.
So 80 hexadecimal is 128 in decimal.
Why do we have this at all? Why are we having a hexadecimal 128?
Because hexadecimal is easier to work with when you're doing stuff in base 2. For binary stuff, it's easier to work with hexadecimal.
Oh. What is this? What does it do in the code here?
Well,
case?
that one is an interrupt. That expression is an interrupt.
Interrupt.
So what does int do? It's an interrupt. So that's listed in the documentation somewhere. Let me see if I can pull it up.
Oh yeah, I have the thing open.
Basically, what it does is it stops executing the code to do something else. And what it does in this context, because of what we set EAX and EBX to, is it prints out to console.
Oh wow, okay.
Let me find out what it says specifically about what int do. Int.
What if I add another 0 or something to it?
Int n. Okay.
Oh wait, this is like an instruction to print out to the console, like in hexadecimal, but it
has parameters. So that has parameters. The A, B, C, and D register are its parameters, and we've set A and B to 4 and 1 respectively, and that tells it to print out. And so that tells it to print out to console. So specifically, the A set to 4 and B set to 1 are telling it to print out to that console there. And the other ones are telling it what to print out and how to print it out.
Oh, the ones that I commented out?
Yeah.
What to print out and how to... Holy hell.
Yeah, I think the A set to 4 is telling it that it's going to print out, and then the B set to 1 is telling it from what channel to print it out or something like that. And then C tells it the address of the string you want to print out. The C tells it the address of the string it wants to print out, and the D tells it how many characters to print out. That one, what are you talking about, Superbrain? It needs what to be in the ECX register? Thus, the memory address of the string,
Superbrain says X in this case.
It needs the memory address of the string to be in the ECX register. So
if I comment these out, does it print nothing? Or does it break? Oh. Nice. I guess that's the error message you get when it just doesn't work.
Me says Guten Tag.
That's basically what happened there. Is your code just continued executing after, and there was probably bytecode after that it couldn't execute to some error.
Okay.
Your code error because it continued running after it was supposed to stop. It never stopped.
Oh. How does it even know
There
when
was
to
something
stop
to
running itself?
the
Anyway.
EAX1 and int hex 80 is telling it to stop.
Oh,
That's
this is
basically
a
the exit
stop
command.
thingy. Okay.
Like those 2 lines there are basically telling it to stop.
Thank you. Oh, it's okay. So keep that one then. Delete this one.
Mhm.
Oh, nice. So just it doesn't print out. This is the print thing. Let's see what happens if I give it nonsense. If I get error or something, or just... No, it just like ignores it.
Yeah.
It's like, what?
Yeah, it assumes that what you're doing there is trying to make a label, but you forgot the colon on it. So it actually it does just ignore it. Interesting.
Oh, that's cool.
I bet if you just type like add and then didn't put anything after,
Superbrain
then it
says
would give you
God
an
having
error.
to move my
Oh.
function parameters to the correct places before calling the function sure is something.
Yeah, I know. Now it doesn't like that. Cool.
Yeah. Yeah, that gives you an error. Yeah.
Mhm. I see. That's crazy.
So now, one thing that'd be pretty, I'll give you like a list of instructions that I want you to like figure out how to use at some point.
Like things like telling it to print and stuff with like a...
I'll give you the setup, like how you set that up, and like all you need to know is just how to set that up. Like you don't really need to know what like the specific things do or what all the other options are right now. All we need to know for this context is just how to set it up. So
okay, it's just like when they tell you to
set A to 4 and B to 1. That's how you set up print. That's how you set up printout. And I forget. I'm gonna take a look at my code right now.
Yeah,
I think it's 3.
I was gonna say you're
2
like...
for
Where's...
the other
Is
thing. I think it's 3 and 2
platform...
for the other
Oh, you get... That's what Corrupt said. Platform dependent.
Platform depend.
Because
Yeah.
Exorcism said it was cross-platform, and then Corrupt was like, I don't think Assembly's cross-platform. That was funny.
Yeah, I don't think
like-
assembly is
Very-
particularly portable.
Yeah, look at this site. Let me show you. It was really funny. This is what Exorcism said. It's a coding site.
Wait.
Look at this. Oh wait, can I get the introduction again? How do I read it? About? Here, see? Cross-platform.
Superbrain says depends on the processor. No.
What did I put readline? Where's readline? I'm looking at my code.
Oasis says
trying to
I mean
figure out how
it
to
is.
do- Okay, readline.
Yeah, it's just
Okay,
kind of misleading because it's like
Okay,
implemented
okay.
differently on different systems or something.
Okay. Yeah, I figured it out. So, if you set A to 3 and B to 0, then it'll read from the standard input box, the STDIN inputs on the right side. So whatever you type in there, it'll read that and it'll store it in the memory wherever, depending on what you set the parameters to.
If you do what?
If you set A to 3 and B to 0, then that'll set it up for reading whatever's in that STDIN
A
input
to
box
3
on the
and
right.
B to 0?
And then when you do the int 0x80, it'll read
Oasis
from
says
that
like
instead of printing
AMD
to
and
the other.
Intel CPUs support the same instructions to some extent.
So tortured.
Like you see the standard input on the right?
No. Oh, now I do.
STDIN inputs.
Yes.
That's a text box you can type in.
Oh, that's
So-
nice.
Yeah, so that is that you would read from that through the code by setting A to 3 and B to 0, and then C would be the address that you want to store it at, and D would be the amount of characters you want to read. Now the way this works is it starts on the left, and then D if you set D to like 3, it'll read the first 3 and store it at the address that you provided in the C register. But then if you do it again, it'll read the next 3. It won't read the first 3 again, it'll read the next 3 after. There might be a way somehow. I couldn't figure. I think I tried to figure it out. I couldn't figure out. There might be a way to go backwards, but I don't. I couldn't figure it out.
Hmm.
And
So something like
for-
doing something over and over again makes it read a certain amount of characters at a time. Something.
yeah. And as for figuring out where the string ends, I'm guessing it maybe ends. Maybe they have it end in a terminator and a zero.
Superbrain says, so how do I know
then
how
that's
much
where
I
the
want to
check where
read
the string
before I
ends.
read?
So how do you know how much you want to read before you read? So the way I did it is, I think.
Oh.
Wait, I could just look at my
Oasis
code.
says it's
I just
null
look at my code.
terminated.
So what I think I did is I looked for when it was a. So the input ends when the input ends when you get the number 0. It's null terminated. Yeah. So they have the standard input null terminated. So that's how you know when the input ends, because you can't enter the null character into that text box. So yeah, Aya has it. Yep. The only way to do that is with
Superbrain
loop.
says, well, I guess that makes sense. Is the only way to do this a loop then?
Yeah.
It's
This
correct.
doesn't. This doesn't.
Me says, who's the phasmophobia guy speaking?
This doesn't. Yeah. This doesn't give you the length of the string. We're gonna want to have the length of the string later on, but yeah, this doesn't. I'll be back. Give me a second.
Okay. While you're gone, I'm gonna look at what this stuff says. C has this, I guess, start thing in assembly inside of it.
Oasis says, why are you learning assembly again, LUL?
Cause Corrupt was like, let's learn assembly. I was like, okay.
Superbrain says, I
Corrupt
once
uses
worked
assembly,
on
so
reverse
he's here,
engineering
so,
some serialized game data. They had
running an
length
experiment.
prefix null terminated
I
strings.
volunteer as tribute. I volunteer as lab rat. I'm down. I'll do my best. I hope I don't fail. I want to be successful. I feel like it's like Portal, you know? Corrupt gets to be GLaDOS, but Corrupt is like a very nice GLaDOS. I get to be Chow. I just gotta not fail. And I'm also not gonna kill Corrupt at the end either, so. Reverse engineering some serialized game data. Oh, that seems cool. That sounds like a difficult challenge.
What are you trying to do?
Oh, I'm just reading what Superbrain said about they once worked on reverse engineering some serialized game data. Length, prefix, null terminated strings. Ooh. I hope so. I hope so.
They had
Oasis
length
says, is he
prefix
going to
and
sing
null
at the
terminated
end
strings.
as well?
I mean, I guess the use for that would probably be if you need to pass that string into some functions that check until null termination, and some functions that check for length prefix. Depends on that actually makes sense if you want to use it like without problems for those kinds of functions that check that work with strings in those different ways. Mm-hmm. Yeah.
Superbrain says the null was explicitly part of the string.
Yeah, it kind of makes sense.
Hey, this one writes Hola Mundo. That's cute. Instead of Hello World. Maybe you wrote this code. Oh wait, this is. Oh yeah, no, this is main. Next.
Superbrain says don't go defending them. I've been antagonizing Ubisoft Montreal ever since.
Oh, Ubisoft. RDI.
That's
Mhm.
That's an 8 byte register,
Oh, okay.
which we won't have in JDoodle.
JDoodle won't have that.
We're working with 32-bit, not 64-bit.
Ayaweza says that's a
Oh wow,
register.
this is 32. Okay, this is 32-bit. So just like
Yeah.
less stuff. Is that what it means? Just like less memory and less stuff.
Yeah, the registers are smaller. They're not
Oh.
64-bit. You can't store 64-bit numbers in them.
Oh, you can store less in each register. Okay.
Mhm.
Okay, that's cool. It's like they don't want their games reverse engineered. Maybe he's not. I feel like as long as I make a game, if I ever make a game that's not, as long as it's not competitive, I don't really care. Like, if people reverse engineer it. Like, if anything, that's cool. Especially if they make mods and stuff.
Yeah, well, you want people to do that. You want people to make mods
Ayaweza
because
says the E prefix means
mods
that
are how
those
your
are
how your
32-bit long.
game
Will survive, continue
yeah.
forever. And people will. It's how the community. Mods are how the community engages with games.
Yeah, that's why getting over it stayed like
Relevant.
semi-relevant for longer than for like a good amount of time. A good
Yeah.
amount of time after like all the big famous YouTubers stopped playing it because a bunch of people were making mods for it and people were playing those mods.
It's cool. The E prefix means that
Me says I didn't know that Ayaweza.
Oh, so just whenever you see E prefix, you know 32-bit. Like it can't be a 64 one.
Yeah.
Ayaweza
Yeah,
says
E prefix
X,
means 32-bit.
BX.
So
means
R is
64-bit.
64.
And then
Okay.
if it ends
Oh,
if it's
X 16 bits long.
yeah, if it doesn't have either of those but it ends in X, then
Ayaweza
it's
says hot. Al
then
equals
it's
8
16.
bits.
AH and AL are 8 bits, yeah.
Damn, Aya, you did not lie to me when you said you know how to code in assembly. I remember when you told me that, and you also told me like you were good at Binding of Isaac,
He
and
thought
they
you
turned
were
out to be
lying.
really good.
Ayaweza says
They thought you
AR
were
is
lying.
for 64.
Shut up, Corrupt.
They're like no fucking.
No,
way
just
you're
Aya
not-
just says
you're
really.
too stupid
Aya
for
just
that.
knows a lot of stuff. Aya knows how to speak
They're
Japanese.
just like no, you're too stupid to know assembly. That's what they thought.
No. Oh my God, Corrupt.
Hang on, my words, that's theirs. They were telling me about it before stream started yesterday.
Oh my God, he's
They were
lying
telling
out
me
of
a lot
his
of things
teeth.
before stream started yesterday.
You're more mean than GLaDOS. Damn. He doesn't even know you. He doesn't even know how to pronounce your name. He's like, how do you say your name?
Yeah, no, I just forget.
Uh-huh.
Ayaweza says, are you okay, buddy?
Wait,
They're
which
talking
one
about-
of us is Buddy? Just like, which one?
They're talking about you.
They're talking about you. It must be you.
What are you doing here?
Assembly's hard.
So,
That's my conclusion. This is harder than I thought it was gonna be.
so they read out the list of instructions.
I don't hate it
I know.
necessarily.
Yeah,
Yes.
so like the whole thing is going to be a lot of breaking the stuff down into really small problems. Like when we're doing all this stuff in JDoodle, one thing that that's going to be pretty prominent is that everything that you want to do, you have to do it yourself.
Okay.
The one thing that you have that you'll have
Oh, I went
handed
too
to
far
you
down.
is reading and writing from console and input.
So I'm only gonna read
Yep.
and write from console, and then just do math. The rest of it, it's just gonna be doing math.
Always says ain't hard. It's just you don't know enough programming LUL. Like you don't even know how to read binary or hex.
I can read binary. I literally watched a video reading binary, and you were there. Do you like not remember that? Are you crazy?
It's that they haven't. It's really just that they aren't. They literally just started. That's why it doesn't make sense to them, because they literally just started a whole brand new programming language. It's
Okay, I'll tell you what number that is. And I watched. You were there. You can't believe you forgot this. Hold on. That is 2, 4, 8, 9, 10, 11. See, it's 11. It's just powers instead of
11.
Decimals base 10, binaries base 2. You just do the same thing with 16. So it would just take me time to calculate it, because it's like 15, and then once you reach 16, it goes to the next column.
Of me says B.
Oh, read that. Oh, read 1011 in hex. Damn, you already answered all me. I didn't even get a chance.
Yeah, all me's literally hearing you. Like, I'm assuming this is 1011 in binary. Because, 1011, that could be 1011 in hex, in octal, in decimal, in hex, in binary.
I know how the pattern works. It's just like decimal, but with less places.
It could be 1011 in base pi. Like, what are we talking about here?
Base pi, please. I don't want base pi to exist ever. Don't ever say it again.
There's a video that talks about how to do that.
What about base? What about base I? Right.
I think that exists.
I hate it here.
Well,
no, it doesn't. No, it doesn't. It can't. No, base I.
It's like binary.
But I. It does. This is dumb.
Yeah, thinking about it, it's literally just like binary. I think. No, well, actually.
Oh, it's like.
No, well, it wouldn't be exactly like binary. I think, because it'd be weird. It'd be like base 1. I think. It'd be kind of like base 1.
So, what is that one called again? It's called unary. Unary.
Yeah, you represent like let's say like 5 as 5 ones, or 10 as 10 ones. It'd be kind of like that in base I.
Yeah, but seriously, I don't know why Aya is so determined, because Aya said this before in previous streams, like, oh, you don't know binary, but he literally showed up for an entire stream while I was learning binary, like from CS50 in the first lecture. It's literally the first lecture of CS50. Binary is not crazy. It's not a hard concept, but doing math with binary, that's hard. I just know how to, I know how the system works, but the patterns of how to do math, like flip the digits, blah, 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 if you subtract or multiply, like digits flip, and it's kind of complicated, right, and stuff. So I don't really know how to work well with binary and use, like, bitwise operators, but I know what binary is. I hate this tutorial. I don't think this is a good beginner tutorial on this website.
I always says what I mean. It's that you should get a bit more used to it. That's all, with easier stuff.
I'll get plenty of that. I'm not just gonna spend.
I'm running out. I'm thinking, what am I trying to do? I'm like writing out this list here.
Oh, you're right. Okay, I'll wait for you to send over stuff. Take your time. But don't worry, I'll get plenty of practice doing easier stuff. I'm not just gonna. What do you think? I'm just gonna spend the rest of my life just doing this? No. As you know, in my streams, I like to jump around a little bit here and there. mess with things, see how things go. I'm not afraid to experiment. That's the fun of streaming. And then I'll have my usual activities. I'm obviously doing Khan Academy. I'm working through the CS50 course, which is an intro to programming course, so where I'll get to learn the basics of actually using just C, regular C, and then doing problems on like exorcism with like Python, and easy problems with Python and C#. And I actually own my own like C# courses. Like there's some that I was doing in the past that I have to go back and start doing. And then like Unity courses and stuff too. I need to start. At some point I'm gonna need to go back and start messing with Unity again. But I think it's fine to like improve my foundation with coding and math right now. Because Unity adds more complication on top of that. Because then you have to learn the UI, and you have to learn all the special Unity classes and stuff that they give you. Which is like an extra... A whole extra can of worms.
Mm.
That's a horrible
Oasis
idea.
says you want to make games, right? Why don't you start doing some OpenGL?
You're telling me, oh, assembly is too high for your level right now, and you're asking me to do OpenGL? You're funny.
Oasis says what?
I think you can answer your own question. Damn. But yeah, I would look into OpenGL if I got an OpenGL.
Oasis says OpenGL it's way easier than assembly LUL.
Which I haven't learned yet.
Oasis says it's just linear algebra.
But I would do OpenGL if I had someone in chat here who was gonna give me a whole walkthrough of OpenGL. Then sure thing. It just so happens that Corrupt's here. You know, who's happy to help me.
There's no control F in here.
Who knows? Corrupt's here, who's happy to help me with assembly. So of course I'm gonna, you strike while the iron's hot. I might never get this opportunity again in the future.
Oasis says there are plenty
Yeah,
of
because like
websites.
if I die in basic training when I'm in the Marines, then
Shut up! Don't. You're not gonna die, and don't die, I'll be very disappointed in you. If you die.
Well, I won't be around to experience that.
Well, yeah, but I'm still gonna be disappointed.
https://learnopengl.com.
Oh, I didn't know that, Aya. That doesn't mean, but people can also be disappointed too. There are plenty of websites. Your Wagamama.
Oasis says don't be.
Did I ever use this function? Did I?
Nice.
Me says Python. Last year I coded linear algebra from scratch.
But yeah, take your time, Corrupt. I'm gonna, while you're doing that, I'm gonna divert and answer some problems. So you have plenty of time. Just, there's categories. What
I'm trying to
category?
figure out if I ever use this one function somewhere so I can figure out how I did it.
Oh, okay.
Paste it in here.
Okay, this is grade 5 because I apparently forgot a few curriculums, like TX text. I didn't know this existed, so now I have to do this too.
Okay, I'll use
Goddamn.
that function once. Okay, well I don't know what this function does because I didn't use it.
66 minus 12. I can't remember as many digits in
Me
my
says
head.
54.
Yeah, 4. 6 minus 1 is 5. 54. 20 divided by 4. 5. 6. 20.
Me says 5.
10. So 16, 17 plus 7. 14. Damn it, I did it wrong. Oh, wait, what am I doing? 17 plus 7. Why did it say 14?
Me
24.
says 14.
Did you just make the same mistake as me, Obi? It's 24. Again.
Me says Dio.
Yeah.
Me says 7.
The test is
236 minus 4. That was loud.
come on.
I feel like 4. 11. I guess this is 55. 4 about 53.
Me says 55.
They used a coupon for $2 off the total price of all the items.
Solution's 300.
Shouldn't be determine the price of the items are bought. Yeah, 4 times. 50 cents. Where's $5 come from? What's total price of all items? Oh, this is the total price. Oh yeah, $5 for each bread. Never mind. That's interesting. 5. Oh yeah, you can do this because it's distributive. Okay, so 450.
Okay, right, okay.
Me says 15.
7, 8, 12, 16, 17, 18, 17, 16. What's up? Corrupt.
Okay.
The train has 4 golden donor 15 bucks each. 20 bucks store for 5 $7. Ooh, you typing something? Are you manually typing that all out?
Wait, what?
Oh, it just says you're typing. Like, are you manually
I
typing all
am.
that instead of copy pasting? Oh wow.
I'm typing. I'm typing. I'm typing a bunch of things out.
Oh, that's so nice of you.
Ayawaza says I'll have some food. Good luck with your bankyo.
Aw, thank you, Aya. Good luck with your, food. 美味しく食べてね。Okay, I'll wait for you to send that. I don't want to interrupt you. 15 books each. Yes, the local books. Yeah, yes, local books are doing 20 books. And the store owner added 5% books. We repeated this book drive in 3 different towns with the same amount of books. Now you're doing them all to a community center. So 60, 70, 85, 85 times 3. Wait. 8, 16, 24.
Me says 255.
5, 10, 15. So. 255. Two is 8. 2. 28, 28, 40. 56.
Me says 54.
56.
Me says Dio.
Oh. One thing to be careful of is corrupt is if your message is too long, it won't send. Like Discord won't let you send it.
No, it'll tell me if it's too long. I'll know.
Oh, it will? Okay, good. Because I've tried to send messages before. I didn't say anything, and then it was just like, it can't send because it's too long. And I'm like, God damn it. And I had to like break it up into pieces, and it was sad.
No, it usually says like on the side.
Oh.
It'll have like red stuff that says like.
Oh, yeah, you're right. Actually, it's because I was
how far over the character limit you are.
Because I was trying to copy and paste my message into Discord. That's why I was like, oh, damn it. Then I had to break it up. Maybe I should do exactly what you did and use the resources you did. Tutorial point. Because these other ones are like, I don't think they're that good. For someone who doesn't know C.
Yeah, I'll see if I can find this tutorial.
Yeah, it's probably just tutorial point. Like, I can just browse the site and go to assembly. But I want 32, the 32 assembly, right? That's what we're using.
NASM. Like, it might be called NASM or x86.
Oh, okay.
Either of those.
I thought x86 was the 64 one.
I'm just saying that those might be called those two, either of those two different things too.
Oh, okay.
That's all you need. It's NASM or x86. It's probably what you're looking for. What you need.
Okay, I'm gonna Google what does NASM mean. It's definitely not National Academy of Sports Medicine. John Morning alarms. Net-wide assembler. An assembler for the 86. Portable to nearly every modern platform. So what does an assembler do? It turns the assembly into machine code?
Yeah.
Oh, okay. That's cool.
Sorry, it took me a bit because I was looking at something else.
I'll be right back. I'm use the bathroom.